Hello there, and welcome to Just About Earth, where curiosity drifts as gently as the tide and science becomes something you can almost fall asleep to. Tonight, we'll wander somewhere quiet, somewhere blue and endless, somewhere that keeps its secrets very well. Beneath the rolling skin of the oceans, there are places we've barely seen, shelves of rock and sand where perhaps, just perhaps, the traces of something old still rest. Older than the pyramids, older than writing, maybe even older than the idea that civilization had a beginning at all. It's a thought both vast and oddly soothing, that the world might have lived many lives before ours. Before we sink too deep into that mystery, take a moment to notice where you are. Maybe you can hear a bit of night outside, or the hum of a quiet room, or just your own breathing. All of those sounds are part of your own present moment, the one you happen to be living in while we talk about things long gone. And while we travel through time and tide tonight, I'd love to know, where are you listening from? Are you near the coast, somewhere you can smell salt on the air? Or maybe you're far inland, where the idea of the ocean feels like a dream. Either way, this story belongs to you too, because wherever you stand, you're standing on what used to be the sea. If you find this gentle unravelling of questions relaxing, if it helps your mind wander toward calm curiosity, it would mean the world if you'd like this video or subscribe. It helps this little corner of quiet reach others who might need a slow, thoughtful voice to fall asleep to. Now, if you're ready, let's begin to drift a little deeper, not all at once, but the way a thought sinks slowly until it touches something hidden and ancient. The ocean covers more than 70% of our planet, but we've mapped only a fraction of its floor with any real precision. Most of it remains as unknown to us as distant planets, a terrain of mountains, valleys, plains, and ridges hidden beneath kilometers of water. Every year, new shapes appear on sonar maps: canyons, plateaus, collapsed volcanoes. Some look strangely deliberate. Some, if you squint just right, could almost be mistaken for the remnants of walls, terraces, or paths. Most of them aren't, of course. Nature has a habit of sculpting beauty that feels human, but once in a while, a pattern seems to whisper something different, something that feels intentional, as though a story is murmuring beneath the silt. To wonder whether a civilization might have come before ours isn't new. Humans have been asking that for as long as we've told stories. Legends of lost continents, sunken kingdoms, and forgotten cities run through nearly every culture. Atlantis is only the best-known example because Plato wrote about it. But there are others. Mu, Lemuria, Kumari Kandam, the land of the drowned gods in the myths of the Pacific Northwest. All of them share a strange common thread. The idea that something once existed, flourished, and then vanished under rising seas. It's tempting to dismiss that as coincidence or imagination, but every myth begins somewhere. Sometimes in memory, sometimes in metaphor, sometimes in something half-remembered that the earth itself decided to hide. The story we're exploring tonight begins about 12,000 years ago, at the end of the last ice age. At that time, much of the planet's water was still locked in glaciers, and sea levels were more than 100 meters lower than today. The coastlines of that world looked completely different. Continents were larger, islands were connected, vast plains now underwater stretched far beyond what we now call the shore. People lived there. Not a myth, not a theory. Archaeology tells us they did. Hunters, gatherers, early settlers followed rivers and coastlines, because that's where food and mild weather gathered, and then gradually the ice began to melt. It didn't happen in a single dramatic rush, but in pulses, slow, steady rises, interrupted by sudden bursts, events so powerful they redrew maps. Floods swallowed valleys and forests, shorelines retreated by kilometers in a single human lifetime. Whole landscapes where people had built homes and fires and stories disappeared. For those who lived through it, the experience must have felt like the end of the world. Perhaps it was. When we talk about the first civilizations, we usually start with Sumer, Egypt, the Indus Valley, China. Cultures that emerged around 5,000 to 6,000 years ago, when the seas had already stabilised. But that's because those are the ones we can see. Their ruins are above water. Their artefacts have survived. The question we rarely ask is simple. What if others came before them, during the long melt, on those now drowned shelves of land? If humanity had already built something complex along those ancient coasts, how much would we have left to find today? That's the quiet puzzle at the heart of tonight's journey. Because the ocean is not kind to memory. Wood dissolves, stone erodes, metal corrodes, even mountains crumble over millennia. The sea reclaims everything, polishing it down to anonymity. If an early civilization had once flourished there, one with villages, temples, maybe even simple trade, it wouldn't take long for the evidence to vanish under sediment. Not gone completely perhaps, but hidden so deeply we'd need machines to find it. Still, sometimes the ocean leaves clues. Off the coast of India, near Dwarka, divers have found submerged structures arranged in geometric patterns that some think could be remnants of ancient cities. Off Yonaguni, near Japan, a massive stepped formation lies beneath the waves, shaped so sharply it's hard not to imagine human hands at work. Off Malta, there are lines carved into bedrock that vanish into the sea. In the North Sea, between Britain and Denmark, sonar reveals the ghost of a vanished land called Doggerland, a broad, fertile plain that once connected islands now separated by deep water. Archaeologists have dredged up tools, bones, and remnants of forests there. People lived in that world. They watched the sea rise. They walked away as the water crept inland. If you look at the ocean not as a boundary but as a kind of mirror, you begin to realise how much of our history lies behind it. The first harbours, the first fishing settlements, the first attempts to tame the tides, they would all have been built at the edges of the world as it was then. And every few centuries that edge moved. The sea swallowed its own witnesses. What we now think of as the beginning of civilization might simply be the beginning of what's left above water. This idea isn't about fantasy. It doesn't need lost technology or forgotten gods. It only needs time. Time enough for the sea to rise, for memory to erode, for stories to turn into myths. Because humanity has been around far longer than our written history suggests. Homo sapiens as we are now have existed for at least 300,000 years. Civilization as we define it, cities, writing, agriculture, covers barely the last 5,000. That's 1.5% of our time as a species. So what happened in the other 98.5%? Were we simply wandering, forever primitive? Or did we build and lose and start again, over and over, leaving faint traces behind each time? It's a humbling thought that we might not be the first to reach this point of complexity, only the first whose record survived long enough to be read. The ocean might be keeping the others. Down there in the cold dark, there could be stone circles worn flat, tools buried under silt, or entire settlements encased in sand. We found hints of such things already, but they're rare, because exploring underwater archaeology is slow, expensive, and dangerous. For every square kilometre of ocean floor, thousands remain unseen. We're still in the infancy of searching. The technology that could help us, high-resolution sonar, deep-sea drones, sediment DNA analysis, is only now reaching the precision needed to pick out traces that small. Until recently, we could only guess. Now we can scan entire coastlines, tracing the faint outlines of riverbeds and deltas that fed ancient populations. Each year reveals more, not grand temples, not proof of a forgotten super-civilization, but quiet confirmations that people lived along those vanished shores. And where people live, culture follows, memory follows, maybe even the first sparks of something we'd call civilization. Imagine a small settlement on the edge of the Sunda Shelf, 15,000 years ago. The sea is miles away. Forests stretch toward what is now Indonesia. Families build huts, fish in shallow lagoons, watch the stars rise over lands that no longer exist. They live there for generations. The water rises so slowly that each child grows up thinking the shore has always been this close, until one day it isn't. Their descendants move inland, carrying their tools, their songs, and the faint ache of remembering where home used to be. They tell stories about the flood. Over centuries, those stories become myths. Thousands of years later, someone writes about a lost land beneath the waves, and no one realizes it was memory all along. That's what this whole question is really about. Not whether Atlantis was real, but whether memory itself can outlast the ocean. Whether traces of our species' earlier chapters might still linger somewhere out there, waiting for a curious diver or a quiet sonar ping to notice. The ocean doesn't advertise its secrets. It guards them with silence and salt and darkness. But sometimes, on a calm day, when the water is clear and the sun reaches down through layers of blue, you can almost believe it's whispering back. So we keep listening. Each expedition, each new scan, each artifact pulled from a fishing net adds one more piece to a puzzle we may never finish. Maybe we don't need to. Maybe the mystery itself is part of what keeps us looking, part of what keeps our curiosity alive. The ocean holds not just the remains of possible civilizations, but the reflection of our own desire to find them, to connect with something older, something that proves we've always been reaching beyond the horizon. And as we drift onward, there's something deeper to consider. The ocean's memory isn't just geological, it's biological too. Currents circulate for centuries, carrying microscopic traces of everything that's ever touched the sea. Every river that empties into it brings silt from mountains, soil from forests, pollen from flowers, ash from fires. Even if no ruins survive, the ocean may still remember them in its chemistry, in the sediments that rest quietly mile after mile. When we study those layers, we're reading the diary of the planet itself, written in plankton, minerals, and time. It's easy to forget that our planet is still changing. Coastlines are still shifting, ice still melting, seas still rising. 10,000 years from now, much of what we build today might lie beneath the waves as well. Future beings, whoever or whatever they are, might wonder the same thing about us, whether we ever existed, and if so, why so little remained. The idea loops endlessly, like a tide that comes and goes but never really ends. As we move deeper into this story, it becomes less about proving or disproving and more about perspective. The ocean, after all, doesn't care for our definitions of civilization. It doesn't distinguish between stone tools and skyscrapers, between myths and data. It just moves, erases, renews, and maybe somewhere under that steady rhythm, there are still traces of the first human dreams built close enough to the sea to be swallowed when the world changed its shape. The thought lingers like the echo of a wave retreating across sand. And as we drift onward, toward how the planet forgets and remembers, we can almost hear that soft, ceaseless whisper beneath the waves reminding us that the story isn't over. It's only sinking into its next layer, waiting quietly for light to find it again. The planet that forgets slowly does not forget in anger or haste. It forgets with the patience of water tracing the same path for millennia, wearing stone down to sand, letting each grain find a new place to rest. Earth's memory is long, but it is written in a language we can barely read. Every continent, every mountain, every shifting current is a page that's been turned, overwritten, folded, or lost to time. When we look for traces of our past, or perhaps a civilization older than the ones we know, we're really asking a very small question of a very large storyteller. And that storyteller replies in the language of erosion, subduction, and drift. Beneath the still surface of the ocean, the Earth is moving constantly. The seafloor is not static. It is born and destroyed in cycles that span millions of years. Along the mid-ocean ridges, molten rock wells up, forming new crust that slowly spreads outward. On the other side of the world, that same crust plunges back into the mantle through deep trenches, carrying with it everything that once rested above. Fossils, sediments, perhaps even the remains of some forgotten human effort. all drawn down into heat and pressure beyond recognition. The ocean floor we see today is young by geological standards. Most of it is less than 200 million years old, a blink in Earth's long chronology. Compare that to the continents, which have persisted for billions of years, and you start to understand how thoroughly the planet renews itself. If a civilization had ever risen on land now buried beneath the sea, the odds are high that its foundations have already been recycled into new crust, the memory of it transformed into magma. And yet, even in its amnesia, the Earth keeps hints. The sea floor, like an old canvas, bears faint brushstrokes of its history. Sediments drift down from above, forming layers that trap tiny fossils, ash and minerals. Scientists collect cores from the ocean bed, long cylinders of mud and sand, and read them like diaries. Within those layers lie stories of ancient climates, volcanic eruptions, and even the rise and fall of sea levels. Sometimes they reveal sudden spikes in carbon or changes in isotopes that suggest enormous floods or glacial melts. Each of those events could have redrawn coastlines and drowned whole ecosystems, including any people who might have lived there. If you could hold a single grain of sand from the bottom of the sea and know its history, you'd see continents shifting above it, rivers forming and vanishing, mountains eroding into dust. You'd see generations of creatures evolve and disappear, and somewhere, perhaps, you'd see the faint shadow of human movement, footprints pressed into what was once a shoreline now hundreds of meters underwater. The sand doesn't tell you names or dates. It only tells you that something once was. The reason our planet forgets is not cruelty, but motion. Everything here is restless. The crust floats on molten rock like cracked ice on a slow river. Winds scrape mountains down grain by grain. Rain fills the cracks and freezes and widens them. Rivers carve valleys and deliver their sediments to the sea, where currents sort and spread them into patterns that seem random, but are anything but. Over thousands of years, those patterns bury everything built by hands. In a few million more, tectonic drift will raise those sediments into mountains again, where they will erode once more. It's an endless cycle of remembering and erasing. If Earth had a face, it would never look the same twice. 10,000 years is enough for an entire coastline to shift. 100,000 can birth a desert or a glacier. 1,000,000 can close an ocean. Civilizations, with all their stone and ambition, exist for moments within that scale. We call ancient what is barely visible to geology. The pyramids are 5,000 years old. The Grand Canyon took 6 million to carve. The ocean has reshaped the continents many times over since. So when we wonder whether an early civilization could have existed and been lost beneath the waves, it's less a question of possibility and more a matter of how easily the Earth might have turned the page on them. The process is subtle, but relentless. When sea levels rise, salt water seeps into soil and weakens stone. Waves erode foundations, storms pull structures apart, and tides deposit silt that hardens over time into rock. Coral grows over ruins, turning walls into reefs. Sand fills courtyards. Fish move in. Within a few centuries, a city becomes indistinguishable from the landscape. Within a few thousand years, it becomes the landscape. We've seen it happen in slow motion along modern coasts. Places abandoned for only decades already being reclaimed by dunes and mangroves. Give it enough time and the line between nature and memory blurs completely. This is why the ocean is both the best and worst place to hide a civilization. Water preserves in some ways. It can seal objects in layers of mud, protect shipwrecks from oxygen, but it also grinds everything soft. Currents act like hands endlessly polishing surfaces. Coral, algae, and bacteria colonize everything. Over millennia, even granite yields. What remains after that isn't ruin, it's geology. The evidence of life merges into the planet's structure until it's no longer clear whether what you're looking at was ever alive at all. Scientists sometimes refer to Earth's crust as a palimpsest, a reused parchment that's been written on and scraped clean countless times. You can still see traces of the older writing beneath the new, but never the full text. When geologists read the rocks, they're reading fragments of a billion erased stories. In that sense, the Earth hasn't truly forgotten. It's just that its memory is written in layers, and most of the earlier ones are sealed away. The challenge of finding any trace of an early civilization beneath the sea lies in the speed of change compared to our brief history. The end of the last ice age was recent enough that some ancient coastlines remain preserved beneath sediment. Doggerland, for instance, lies beneath relatively shallow water, and its features, rivers, hills, peat bogs, can still be mapped with sonar. If there were settlements there, they might be buried but not destroyed. The same goes for the Sunda Shelf, the Persian Gulf Basin, and parts of the Caribbean. These were vast, habitable plains when the seas were lower. The geological clock hasn't yet erased them entirely, but go further back, 50,000 years, 100, and the story becomes harder to read. The ocean's handwriting becomes illegible. What makes this even more fascinating is that Earth's forgetfulness isn't uniform. Some regions preserve history with remarkable clarity. Dry deserts, frozen tundra, deep caves all act as natural archives. But the ocean is an editor. It doesn't simply bury, it revises. It pulls apart and reassembles, mixing materials from different ages. An artifact found on the seabed might have travelled miles from where it began, carried by currents that never stop moving. So even if we do find something that looks deliberate, we must ask, did it form here, or did the ocean bring it? Was it built, or merely shaped? In the last few decades, researchers have begun to use technologies once reserved for planetary exploration to study Earth's own depths. Multibeam sonar creates detailed maps of the seafloor. Submersibles can hover above ancient river valleys, tracing the outlines of what could once have been pathways. Computer models reconstruct coastlines at different sea levels, revealing how vast the world was when ice still ruled the poles. Each new discovery brings more complexity, not clarity. There's evidence of human presence along nearly every ancient shoreline we can reach. Tools, carvings, hearths, nothing impossible, but enough to remind us how incomplete our story is. The ocean's forgetfulness also extends to climate. It records the rhythm of the planet's heartbeat in its temperature, its chemistry, and its currents. Ice cores and sediment layers reveal that Earth moves through cycles of warmth and cold, expansion and retreat. With each change, the sea reclaims or reveals land. Civilizations rise during stable periods, then vanish when balance shifts. It's easy to see this pattern in our own time. The same forces that may have erased ancient worlds are at work again, quietly reshaping the coasts we call home. Sometimes, when scientists drill deep into the seabed, they find layers of sediment disturbed in strange ways. Fine lines of ash from volcanic eruptions, sudden influxes of freshwater species, traces of organic carbon suggesting floods of life and death. These are not human fingerprints, but they are reminders of how quickly the world can change. A single massive meltwater pulse, like those that ended the Ice Age, can raise sea levels by meters in a matter of decades. For people living then, that would have been within a lifetime, a creeping catastrophe that turned valleys into bays and homes into reefs. If any culture had built along those coasts, its story would have ended beneath the tide. The slowness of Earth's forgetting can be deceptive. We measure time in years, but the planet measures it in layers. Each centimetre of ocean sediment might represent hundreds of years of quiet accumulation. A single landslide can bury a landscape in minutes and preserve it for eternity. Somewhere down there, under kilometres of pressure and darkness, those moments are still entombed, like pages glued together. They wait for someone with the patience to peel them open. And yet, the more we learn about the ocean's ability to erase, the more miraculous it seems that anything survives at all. There are shipwrecks thousands of years old lying almost intact in anoxic waters. There are wooden canoes preserved in mud, human footprints fossilized in clay. There are shells carved into jewelry by hands long gone. Each survival is an act of defiance against time's tide. And if these small things can endure, perhaps something larger did too. Perhaps somewhere beneath the silt a pattern of stones remains in formation, waiting for a scanner to pass overhead and notice. The planet that forgets slowly also remembers selectively. It keeps what fits into its cycles and discards what doesn't. It records catastrophe with precision but loses the quiet days. That's true of our written history as well. We know about wars and extinctions, but not about ordinary mornings, not about the laughter or fears of people who watch the shoreline change. If an ancient civilization did exist along the now drowned coasts, what would it have looked like? Maybe it wasn't monumental at all. Maybe it was a network of villages, fishing communities, artisans, traders. Maybe civilization's first heartbeat was quieter than we imagine, and the planet's slow forgetting simply erased the subtle signs of it. We often think of history as linear, a rise from simplicity to complexity, but the Earth suggests something cyclical instead. Cultures could have emerged, flourished, and disappeared more than once, each time leaving a little behind, enough for the next to find. The tools of one age become the stones of another. The stories of one people become the myths of the next. The ocean doesn't stop us from remembering. It simply makes remembering harder. It asks us to listen more carefully. There's a strange comfort in knowing that the Earth forgets slowly. It means that while most details fade, the essence lingers somewhere, transformed but not destroyed. The calcium from old bones becomes limestone. The ash from fires becomes soil. Even civilizations, in some abstract way, become part of the planet's body. Their ruins turn to minerals, their metals to dust, their stories to sediment. They are gone, but they are also everywhere. If we could see time the way the planet does, we might realize that forgetting is just another form of transformation. Nothing truly disappears, it only changes shape. The sea that swallowed the coasts of early humans also gave rise to new habitats, coral reefs, and currents that nourish life today. The erasure that frustrates archaeologists is the same process that sustains the planet. The Earth forgets, but its forgetting is creation by another name. When we speak about the traces of a first civilization hidden beneath the oceans, we're not just speculating about a lost chapter of human history. We're also acknowledging the sheer power of the planet to renew itself, to smooth over the past with relentless grace. Maybe that's why the thought of something ancient and buried underwater feels so haunting. It's not just the mystery of what might be down there. It's the realization that everything we build now will someday join it. The skyscrapers, the roads, the lights we think will last forever. They're only temporary ornaments on a restless world. And still, we keep building, exploring, mapping. We keep asking questions, even knowing how partial the answers will be. That's what humans do. We dig into the Earth's memory even as it rewrites itself beneath us. Each discovery, no matter how small, is a moment of connection with something larger. When we find a tool or a footprint, we're not just uncovering the past. We're touching the slow pulse of the planet itself, feeling its rhythm through layers of stone and time. The planet that forgets slowly is still forgetting even now. Coasts are eroding, glaciers melting, new rivers forming. The process never stopped, and we're watching it happen from the inside. One day, far in the future, someone else might wonder about us. They might look at the ruins of our cities beneath new seas and ask if they were the first. They'll sift through sediments, pull up fragments, build stories, and wonder about the lives we lived on what to them will be the ocean floor. And the Earth, patient as always, will keep its own counsel, neither confirming nor denying, only moving, only changing, only turning its endless pages beneath the waves. And as that thought drifts gently toward the surface of your mind, you can feel the quiet pull of the current leading onward, toward the time when the seas began to rise and the world started reshaping itself once again. When the great sheets of ice began to melt, it didn't happen with sudden drama, though to those alive then, it must have felt like the world was changing beneath their feet. The process began quietly, almost imperceptibly, with drops forming where once there had been silence, with rivers trickling out from glaciers that had stood unchallenged for tens of thousands of years. The air grew a little softer, the seasons shifted, and the planet started breathing in a new rhythm. For nearly 2 million years, the Earth had moved in and out of ice ages like tides that came not in hours, but in epochs. But around 12,000 years ago, something different happened. The last great glacial cycle began to end, and the world, as humans knew it, began to drown. It's difficult for us to imagine the scale of what that really meant. Today, we picture the Arctic and Antarctic as the boundaries of the frozen world, but back then, ice covered nearly a third of the continents. Vast white domes stretched across North America, Northern Europe and Siberia. Mountains that now seem ancient and exposed were buried in kilometres of ice. Sea levels were more than 100 metres lower than they are today. The planet looked different. The map of the world was not yet the one we know. Where we now have shallow seas, there were grasslands and forests. The British Isles were part of the European mainland. Asia was joined to North America by a vast land bridge. The coastlines of India, Australia and Southeast Asia extended far beyond their current reach. It was a connected world, open, cold, but full of life. When the climate began to shift, it did so for reasons both cosmic and local. The tilt of the Earth, the wobble of its orbit, subtle changes in the way sunlight touched the planet, all combined to tip the balance. Temperatures rose slowly but steadily. Glaciers started to retreat, exposing ground that hadn't seen daylight for millennia. Those rivers of meltwater carried enormous amounts of sediment into valleys, forming new lakes and deltas. The planet's albedo, its ability to reflect sunlight, began to drop as white ice gave way to darker rock and soil, absorbing more heat. The feedback loop was simple. The warmer it got, the faster it warmed. At first, the melting was gradual, spanning centuries. Sea levels crept upward by a few millimetres each year, small enough that any one generation might not have noticed. But then came the meltwater pulses, catastrophic surges that released unimaginable volumes of water into the oceans in a matter of decades. The most famous, known as Meltwater Pulse 1A, happened around 14,600 years ago. In that brief window of time, sea levels are thought to have risen by as much as 20 metres. To coastal dwellers of that age, the transformation would have been impossible to ignore. Valleys became inlets, hills became islands. What had once been distant waves lapping faintly against the horizon were now climbing the edges of forests. Imagine living at that time. You might have grown up in a world where the sea was far away, a shimmering boundary beyond fields and hills. You might have built homes near rivers that fed into that distant ocean. Over your lifetime, you'd begin to notice things changing. The tides reached a little farther inland each season. The fish that once lived in estuaries began to appear closer to your door. And one day, the marsh where your ancestors buried their dead would be gone, replaced by brackish water. There wouldn't have been words for climate change then, no concept of a geological epoch, only the visceral feeling that the world was moving beneath you and that you could do nothing to stop it. Human groups adapted as best they could. They followed the retreating coasts, resettling further inland or higher up the slopes. Archaeologists have found evidence of continuous migration patterns that match the rising seas, footprints of people keeping pace with a drowning world. The tools they left behind, the flints, the carvings, the hearths, speak of resilience rather than despair. They didn't know it, but they were witnessing the birth of the world as we now know it. The oceans, of course, were not passive in this transformation. As meltwater poured in, they changed character. Currents shifted, temperatures fluctuated, salinity patterns broke down. The thermohaline circulation, the great conveyor belt that moves heat around the globe, slowed and sometimes stalled, plunging regions back into cold even as the planet warmed. The Younger Dryas period, A 1,000-year return to near-glacial conditions may have been triggered by this disruption. To those living then, it must have seemed like the climate itself was fickle, generous one century and cruel the next. But the water kept rising. By about 7,000 years ago, the process had mostly stabilised. The last major ice sheets had melted, the great deltas had formed, and the modern shorelines had emerged. Yet, in that span of a few thousand years, more than 10 million square kilometres of habitable land vanished beneath the sea. To put that into perspective, it's an area larger than the United States and Europe combined. Every culture of that time, from the hunter-gatherers of Europe to the coastal foragers of Asia, experienced loss on a scale beyond comprehension. This wasn't the sudden catastrophe of myth. No single night of storms swallowing empires. It was slower, more intimate. It was parents teaching children the new line of the shore year after year, until the old one was forgotten. It was villages moving stone by stone to higher ground. It was the fading of paths, the drowning of forests, the quiet realization that the sea was claiming the past. In time, what remained were stories, tales of floods, of gods angry with humankind, of cities that fell beneath the waves. Myths born not from fantasy, but from memory. And if we trace those myths, we find a remarkable consistency. Cultures separated by continents speak of great floods, of lands swallowed, of survivors rebuilding on higher ground. The Sumerians had their flood long before the biblical one. The Greeks had theirs, with Deucalion and Pyrrha repopulating the world. In India there was Manu, warned by a fish to build a boat. The Chinese told of the flood tamed by Yu the Great. Even in the Americas, indigenous legends speak of rising waters chasing people up mountains. For centuries, scholars assumed these were allegories, spiritual metaphors for renewal or moral cleansing. But viewed through the lens of geology, they could just as easily be cultural memories of the sea's slow invasion. If that's true, then the end of the Ice Age wasn't just a climatic event. It was a defining moment for our species, shaping myths, migrations, and perhaps even civilization itself. When lowlands drowned, people gathered in smaller, denser populations on higher ground. Those forced together by shrinking land may have shared knowledge, traded skills, or organised in ways that laid the groundwork for complex societies. In this sense, rising seas didn't just erase, it catalysed. What we call the dawn of civilization might have been the afterglow of a planetary flood. The archaeological record supports this in small but compelling ways. Around the same time that the seas stabilised, we see the sudden emergence of monumental architecture. Göbekli Tepe in Anatolia, Jericho in the Levant, the early cities of Mesopotamia. These appeared almost simultaneously across regions far apart, as if humanity everywhere had reached the same threshold of readiness. It's as though the trauma of displacement, the centuries of adaptation, culminated in a collective leap forward. People who had spent generations watching the world change beneath them decided to make something that would last. But what if others had done the same long before, when the seas were lower, only to have their efforts swallowed? It's not an extravagant idea. Even simple societies capable of building with stone or earth could have left lasting structures on the coastlines of the late glacial world. Over 10,000 years, those coastlines sank beneath water and sediment. Whatever they built would now lie out of reach, perhaps under layers of silt thicker than skyscrapers. This is where science meets imagination, in a space that's both cautious and inviting. We know the physics of sea level rise. We can calculate the rate of melt. We can model where the old shores would have been. But we can't yet say who lived there, or what they built, or whether their descendants carried fragments of that lost world inland when the water came. We can only look at what's left. Submerged landscapes, isolated artifacts, and the stories that seem to echo across millennia. The rising seas didn't just take land. They reshaped the very character of the ocean itself. As glaciers melted, fresh water diluted the salt, altering the density and chemistry of entire basins. Nutrients from eroding land poured in, fueling vast blooms of plankton. Marine life adapted rapidly. New coastlines meant new habitats. Coral reefs migrated upward, chasing the light as sea levels climbed. In some places, reefs now rest atop ancient forests. The ocean layered one ecosystem upon another, stacking time like sediment. Beneath those reefs and sediments may lie what remains of the first human experiments with permanence. Villages built near rich fishing grounds, trading posts along shallow bays, gathering sites where rivers met the sea. Most of them would have been small, made of wood, bone, and clay. They would not have been civilizations in the grand sense, but they might have been the roots from which civilization eventually grew. Their disappearance doesn't mean they never existed. It only means the sea was faster at rewriting history than we were at recording it. One of the most haunting aspects of this story is its quietness. There was no single day when people everywhere realized that the Ice Age had ended. It was a slow surrender, a conversation between water and land that lasted thousands of years. And yet the consequences were total. The world's shape changed. The air warmed. The patterns of wind, rain, and temperature that define our modern climate settled into place. The Earth we know, the one with stable seasons, familiar coastlines, and predictable weather, was born from that transformation. Everything we call history happened after the seas rose. We often think of water as the giver of life, but in this story it also becomes the keeper of secrets. Every metre of sea level rise-covered territory where humans once stood. Beneath the Mediterranean, the Black Sea, the Persian Gulf, the North Sea, and the coasts of Southeast Asia lie the bones of a world that ended before history began. Some of those places may hold artifacts, but most hold only silence. The materials of that age, wood, fibre, bone, rarely survive. What remains are impressions. The curve of a riverbed, the faint line of a terrace, the ghost of a hearth under layers of silt. When scientists map these underwater landscapes, they're not just reconstructing geography. They're tracing human experience. Each ancient valley once echoed with voices, with laughter, with the sound of animals and fire. Now those valleys are filled with fish and the hum of currents. It's a shift that's hard to comprehend, yet it happened everywhere. Every continent bears that same invisible border between the remembered and the lost. In a way, the end of the Ice Age represents both the greatest erasure and the greatest renewal in human history. The ocean took what it wanted, but it gave us the world we know in return. The rivers we depend on, the climates that nourish crops, the coasts where we build our cities, all of them were shaped by that melting. If the first civilizations did exist before that time, they were erased so thoroughly that only their reflection remains, faint and distorted in the myths that survived. Still, the evidence of change itself is clear. Coral reefs growing atop ancient dunes, marine sediments covering freshwater shells, entire forests preserved beneath saltwater mud. These are the quiet signatures of the world's transition, proof that the boundary between land and sea is never fixed. If we could drain the oceans, we'd see the continents as they were before the melt, a world of vast plains and shallow basins where people hunted, fished, and built. The lost landscapes would stretch far beyond today's coasts, reminders of how temporary all our maps really are. And so, the story of the rising seas isn't just about loss, it's about the persistence of life amid change. Humanity didn't end when the water came, it adapted, it moved, it learned. The ocean expanded, but so did our understanding of it. Perhaps that's what civilization really is. Not the buildings or the tools, but the continuity of curiosity, the will to keep moving, even when the familiar world disappears beneath the tide. The water is still rising today, slowly, steadily, just as it did before. The ice melts again, and the seas creep inland, reclaiming what they once owned. It's the same rhythm, the same long breath of the planet reminding us that stability is an illusion. What happened 12,000 years ago is happening again, only faster under our watchful eyes. And maybe, one day, someone else will look at our drowned cities and wonder who we were, how we lived, and whether we too left stories behind for the next world to find. And as that thought drifts into the background, the picture widens further. The drowned coastlines, the forgotten plains, the whispers of people who once called them home. The world's memory deepens with each layer of water, carrying us onward toward the lands that vanished first and the clues they may still hold beneath the calm blue surface. The shorelines we lost are not gone in the way we think of things as gone. They are simply elsewhere now, folded beneath the surface, preserved in silence. Every coastline we know is a temporary outline drawn by the sea in its current mood. If you could see the planet as it was 10,000 years ago, the map would look familiar yet strangely wrong, like a half-remembered dream. The continents would be larger, the seas narrower, and the borders between them wide and green. Much of what we now call the ocean floor was once land, a mosaic of forests, plains, rivers and settlements that stretched beyond the reach of today's tides. When the ice melted and the seas rose, those ancient landscapes sank in stages. The process was so gradual that generations watched it happen and still couldn't quite grasp its permanence. Imagine living on the edge of what is now the North Sea, when it wasn't a sea at all but a vast expanse of fields and wetlands. To the people who lived there, it would have felt endless, a place of herds and rivers, a place where the wind carried the sound of birds instead of waves. Archaeologists call it Doggerland now, but it was once as real and alive as any country. Doggerland connected what are now Britain and mainland Europe. It stretched from the present-day coast of the Netherlands and Denmark all the way to what's now eastern England. For thousands of years, it was home to communities of hunter-gatherers who followed herds of reindeer and bison across its meadows. They built small camps along rivers and near lakes, left tools carved from bone and antler, and painted their stories in shelters of stone. As the ice sheets melted, the sea crept in from the north and west, flooding the valleys first, then the low plains. Over centuries, the rivers became estuaries, then bays, then deep channels. One day, the horizon changed forever. We know this not from legend, but from evidence pulled from the seabed. Fishing trawlers sometimes bring up pieces of mammoth bone, antlers shaped by human hands, and fragments of peat that once formed ancient marshes. In the mud, scientists find pollen from plants that no longer grow in northern Europe, and traces of freshwater mollusks that could only have lived in lakes and rivers. Sonar maps reveal the ghostly outlines of river systems, hills and shorelines still preserved under layers of sediment. To look at them is to peer into a frozen moment of prehistory, when Europe's heartland stretched beneath what is now open sea. The loss of Doggerland was gradual but inevitable. Around 8,000 years ago, a massive event sealed its fate. Somewhere off the coast of Norway, a section of the continental shelf collapsed in what's known as the Storegga Slide. The resulting underwater landslide triggered tsunamis that tore across the North Atlantic. Waves up to 20 metres high would have crashed over the low-lying plains of Doggerland, inundating them with salt water. For the people living there, it was likely catastrophic. Those who survived fled to higher ground, carrying with them the memory of the flood. That memory, passed down over generations, may be the faint echo we still hear in myths of lost lands beneath the sea. Far to the east, another drowned world lies hidden beneath the waters between Southeast Asia and Australia. During the Ice Age, when sea levels were lower, the islands of Indonesia and Malaysia were part of a single landmass known as the Sunda Shelf. It connected mainland Asia to Borneo, Java, Sumatra and Bali, creating a vast tropical subcontinent larger than India. Rivers the size of the Amazon flowed across it, fed by monsoon rains. The landscape was rich with wildlife, elephants, tigers, giant tapirs, and it would have offered abundant food for early humans. Evidence suggests that people lived there for tens of thousands of years, moving freely across the connected lands. Then, as the seas rose, the Great Plains fragmented into islands, valleys became straits, mountain ridges became archipelagos. Communities that once traded and shared languages found themselves isolated. Over generations, their cultures diverged, their tools and traditions adapting to new environments. The genetic patterns we see in the peoples of Southeast Asia and Oceania today still carry the imprint of that separation. The rising seas didn't just reshape geography, they rewrote the human map. To the south, another land vanished, the continent-sized bridge known as Sahul, which once joined Australia, New Guinea and Tasmania. For early humans migrating out of Asia, Sahul was a single connected region, a continent of open plains, forests and inland seas. As the world warmed, the shallow lands between the islands flooded. Tasmania was the first to be cut off, then New Guinea. The Aboriginal peoples of Australia, whose oral histories stretch back tens of thousands of years, still tell stories of these changing shores. Some describe lands that were swallowed by the ocean, places where their ancestors once walked that now lie beneath the waves. Geological evidence supports these accounts. They correspond closely with the pace and pattern of post-glacial sea level rise. In this way, oral tradition preserves details of landscapes lost 8 or 9 millennia ago, a continuity of memory unmatched anywhere else on Earth. Across the globe, similar patterns emerge. The Persian Gulf, now filled with seawater, was once a fertile river valley. For most of the last ice age, it held a vast basin fed by the Tigris, Euphrates, Karun, and Wadi Batin rivers. Archaeologists refer to it as the Gulf Oasis, a region that could have supported human populations long before the rise of Mesopotamian civilization. When the sea flooded the basin around 8,000 years ago, those people would have moved north, toward the river's upper valleys, perhaps forming the roots of the societies that later built the world's first cities. The cradle of civilization may quite literally have been cradled by a sea that rose to reclaim it. The Black Sea tells another version of the same story. Around 7,500 years ago, it was a freshwater lake cut off from the Mediterranean. Then, as global sea levels rose, salt water from the Mediterranean poured in through the Bosporus, raising the lake's surface dramatically and transforming it into the sea we know today. Sediment layers on the seabed mark this sudden transition. Freshwater shells below, marine shells above. Along the ancient shores of that lake, archaeologists have found evidence of Neolithic settlements that were abruptly abandoned around the same time. The flood was neither myth nor exaggeration. It was a geological event that changed the course of human settlement in southeastern Europe. Even the Caribbean and parts of the Americas hold their share of drowned landscapes. Along the coast of Florida and the Gulf of Mexico, underwater caves known as cenotes preserve the bones of humans and animals from a time when those caves were dry. The Bahamas, now small islands surrounded by deep blue, were once part of a vast plateau twice their current size. The pattern repeats again and again. Wherever the sea now laps, it has taken something older with it. The loss of these lands was not just a geological phenomenon, it was a psychological one. For early humans, the world's boundaries were shifting in ways that defied understanding. The Earth seemed alive, unpredictable, capable of swallowing forests and erasing landmarks. It's no wonder so many myths from this era speak of divine floods or gods of the sea. When the ocean rises into your home and devours your ancestors' graves, it doesn't feel like climate, it feels like judgment. But beneath those stories lies a human truth. We have always lived in dialogue with change, always negotiating with the forces that shape our world. In many ways, the shorelines we lost are the missing first chapters of human civilization. These were the places where early societies gathered, where trade began, where navigation was first learned. Coastlines are natural crossroads. They offer access to both land and sea, to fish and fertile soil, to travel and exchange. If early humans built anything approaching permanent settlements, the coasts would have been the ideal places to do it. Which means that when the seas rose, they didn't just erase homes, they erased the foundations of human community itself. When archaeologists explore ancient coastal sites today, they're often struck by how rich those environments are in evidence of early innovation. Fishing hooks, boats, pottery, tools for weaving and cooking, all appear first along ancient shorelines. It's not difficult to imagine that the same was true for the coasts that now lie underwater. If we could lift the seas away for a moment and walk across those submerged plains, we might find not ruins of lost empires, but something more subtle and meaningful, the fingerprints of humanity learning to live together, to build, to adapt. The evidence for such places is fragmentary but growing. Off the coast of India, near the Gulf of Kambat, sonar scans have revealed structures buried under sediment, aligned in patterns that suggest deliberate construction. In the Mediterranean, divers near Israel and Greece have found submerged stone walls and roads dating back to the Neolithic. Off Japan's Yonaguni Island, an enormous stepped formation rises from the seafloor, sparking debate over whether it's natural or shaped by ancient hands. In the Baltic, off the coast of Germany, archaeologists discovered a stone structure more than 10,000 years old, likely used for hunting. Each of these findings is a small reminder that the human story extends far beyond the visible land. Yet for every discovery there are thousands of square kilometres still unmapped. The ocean hides more of our prehistory than any desert or jungle. The challenges of exploring it are immense. Poor visibility, deep water, strong currents, and the constant decay caused by salt and pressure. Traditional excavation methods don't work well there. Instead, scientists rely on technology, sonar imaging, remote-operated vehicles, sediment coring, to piece together fragments of the past. Each new survey reveals hints of river channels, terraces and formations that could once have been villages. Most remain unverified, not because the evidence isn't there, but because the tools to reach them are still catching up. It's easy to forget that until recently, we didn't even know the full shape of the ocean floor. Only in the past few decades have satellites and sonar given us global maps of it, and even those are rough compared to what we know of the Moon or Mars. That's the irony. We've mapped other worlds more completely than our own. Somewhere beneath those blue expanses could be the remnants of the first experiments in civilization, patiently waiting for the day we finally look closely enough to see them. The shorelines we lost are not gone beyond reach. They're simply hidden in a dimension of time we haven't fully uncovered. Their presence lingers in the sediment, in the genetic patterns of fish and coral, in the stories passed down by coastal peoples. They shape our present without us realizing it. The currents that flow over them influence weather and climate. The minerals eroded from their rocks feed plankton blooms that sustain life across the seas. Even in disappearance, they continue to participate in the life of the planet. If you stand on any modern beach and look out to sea, you're standing on the edge of what was once inland. The waves that touch your feet have rolled over forests, over riverbanks, over the remnants of camps where people once sat around fires. The horizon hides more of our past than the stars ever could. The sea, in its quiet persistence, holds the greatest library on Earth, one written not in books, but in layers of sand and salt. And as we drift further into this thought, it becomes clear that the story of lost shorelines is not just about the past, it's also about the future. The process that once swallowed Doggerland and the Sunda Shelf is happening again. The glaciers are melting, the seas are rising, new shorelines are being drawn even now, and the places we call home will one day be myths of their own. The drowned plains of tomorrow will lie beside the ones of yesterday, part of the same endless cycle of change. When the next explorers, perhaps thousands of years from now, study the sediments of their age, they'll find our traces, the concrete, the glass, the metal, and wonder who we were. They'll see the line where our coasts once stood, and maybe they'll call it by some future name. They'll know that we too lived close to the edge, watching the sea climb, leaving behind our stories as we moved inland, And as that realization settles, the image of the lost shoreline softens, blending into something larger, the memory of a planet always in motion, always erasing and redrawing its own face, always hiding pieces of its past beneath the quiet shimmer of waves. The ocean doesn't forget completely, it just waits, patient and immense, while we keep asking questions it already knows the answers to. And somewhere beyond that horizon, the next part of the story begins, where myths of lost worlds merge with the science of what really lies beneath. The myths that drift up from the deep are not just stories, they are memory, fragile, reworked, stretched across millennia, yet somehow still alive in the rhythm of language. They began as spoken echoes around fires, told by people who watched the sea rise where their parents once walked. Those people did not call it myth, they called it remembering. Somewhere along the long road of time, those memories turned into tales of gods and floods and lost lands. By the time we recorded them in writing, the evidence was already buried beneath the water. What remains now are fragments: Atlantis, Mu, Lemuria, and hundreds of lesser-known stories that cling to the edges of coastlines, each one carrying the faint scent of salt and sorrow. We tend to think of myths as separate from science, but they began as attempts to explain the same thing: the shape of the world. The difference is in method, not in spirit. Science measures, myth remembers. Both try to preserve what time erases. And when it comes to the memory of the sea, the oldest record might not be written in stone or sediment, but in story. Across continents, people who never met told similar tales, of floods that swallowed cities, of lands that fell into the ocean, of survivors who rebuilt on higher ground. These parallels are too consistent to ignore. They might not describe a single global event, but they point to something that felt global to those who lived through it. The rising of the waters at the end of the Ice Age. Plato's story of Atlantis is the one most people know. He wrote it around 360 BCE, claiming to recount an older Egyptian tale about a great island civilization that sank into the sea in a single day and night of misfortune. He used it as a philosophical metaphor, a warning against hubris and the corruption of power. For him, Atlantis was less a memory and more a moral illustration. Yet the power of the story lies in its realism. The details, the location beyond the Pillars of Heracles, the concentric rings of canals, the sudden submersion, sound eerily like the world-shaping floods that ended the last ice age. Even if Atlantis never existed as a physical place, the story resonates because it reflects something humans across time have witnessed: the sea taking back the land. But Plato's account is only one thread in a much older and broader fabric of flood myths. In Mesopotamia, long before the Greeks, the Sumerians told of Ziusudra, a man warned by a god to build a boat before the flood destroyed humanity. The later Akkadian and Babylonian versions transformed him into Utnapishtim, the survivor of a deluge that wiped out the world. His story, recorded in the Epic of Gilgamesh, includes details that feel both mythic and strangely precise. The sending of birds to find dry land, the settling of the boat on a distant mountain. The parallels to the story of Noah are not coincidence. They share a lineage that runs deep into prehistory, back to a time when the people of the Tigris and Euphrates valleys watched their world fill with water as the Persian Gulf flooded. If you travel east, to India, you find another version. The story of Manu, the first man, who was warned by a small fish that a great flood was coming. The fish, an incarnation of the god Vishnu, told Manu to build a boat and gather the seeds of life. When the waters rose, the fish guided him to safety on a mountain peak. This tale appears in the earliest Hindu scriptures, the Vedas, but its roots likely go back to older oral traditions. India's long coastlines and river deltas have always been vulnerable to flooding, and as sea levels rose after the Ice Age, those events must have left deep impressions. The story of Manu may be a preserved memory of one such event, retold until it transcended geography and became cosmic. In China, ancient texts tell of the great flood that covered the land for generations until a hero named Yu learned to control the waters by channeling them rather than blocking them. Unlike the Western stories, this version focuses not on divine punishment, but on human ingenuity, on the act of adaptation. It may echo the long struggle of Neolithic communities along the Yellow River, whose floodplains were shaped again and again by rising waters. The myth endures because it speaks to an enduring truth. The water always returns, and survival depends on learning to move with it. Far across the world, in the Americas, flood stories appear with the same persistence. The Hopi tell of previous worlds destroyed by water, with only a few chosen people saved in hollow reeds. The Maya described a time when the gods sent floods to cleanse creation of imperfect humans. The Ojibwe speak of a deluge that covered the earth, with animals helping to rebuild the land afterward. In the Andes, Incan legends recall a flood that wiped out early humans, leaving only 2 survivors on a mountain peak. Each story has its own cultural meaning, but the common thread remains: the earth once drowned, and people survived. Even in the islands of the Pacific, where the ocean is both home and threat, there are stories of lost lands. Polynesian oral histories tell of Hawaii, the ancestral homeland now beneath the sea. In the Indian Ocean, Tamil legends speak of Kumarikandam, a great land south of India that sank beneath the waves. In Japan, Shinto texts describe how the god Izanagi stirred the ocean to create islands from chaos, a metaphor for emergence after submersion. These myths differ in tone and geography, yet they orbit the same ancient anxiety, that the sea gives life, but also takes it. What's striking is how these stories often contain small, precise details that match what we now know from geology and archaeology. They describe not just generic floods, but specific changes. The sea rising gradually, coasts vanishing, islands appearing. They preserve the emotional truth of an event long after its physical traces vanished. For early humans, storytelling was the only form of recording available. A memory passed by voice could outlast stone if it kept being told. Over generations, the storytellers changed names, added gods, shifted moral meanings, but the shape of the event stayed. The flood myths we read today may be the fossilized remains of first-hand accounts, preserved in culture instead of clay. For scientists studying human prehistory, these stories are more than folklore. They are data, albeit encoded in metaphor. Linguists and anthropologists have begun to compare them systematically, tracing their distribution and evolution. When mapped, flood myths cluster most densely along regions that experience major post-glacial flooding: the North Sea, Southeast Asia, the Mediterranean, and the Pacific coasts. Oral traditions among Aboriginal Australians describe specific drowned landscapes, reefs, bays, and islands that align with geological reconstructions of ancient shorelines. In some cases, the correlation is so precise that scientists use the stories to guide their fieldwork. What once seemed pure legend is becoming a form of unwritten history. The idea that myth can preserve geological memory challenges our assumptions about time. We like to think written history is the limit of knowledge, but oral traditions can span far deeper. Some Aboriginal songlines, narrative pathways across the land, may encode observations of sea level rise that happened more than 7,000 years ago. They speak of ancestors walking to islands that are now submerged, of coastlines that once extended far beyond their current reach. For a culture rooted in continuity, story is not fiction, it's a living map. In the Mediterranean, where cultures have traded and fought for thousands of years, flood legends overlap and merge. The Greek tale of Deucalion and Pyrrha mirrors the Near Eastern flood myths, but with local colour: Zeus instead of Enlil, Mount Parnassus instead of Mount Nizia. Beneath that surface, though, lies a memory of real floods that reshaped the Aegean and Black Seas. When the Bosporus broke open and Mediterranean waters poured into the Black Sea basin, the transformation would have been dramatic enough to inspire generations of awe. To those living near its shores, it might indeed have seemed as if the gods had opened the gates of the sea. Atlantis, despite centuries of speculation, remains the most enduring symbol of these drowned memories. It has been relocated on maps by dreamers to nearly every part of the world, from the Azores to Antarctica, from the Caribbean to the Sahara. Each theory reveals less about the truth of Atlantis and more about our fascination with the idea of a lost origin. We want to believe that something great came before us, that civilization is older than its surviving ruins. But perhaps the real Atlantis is not a single city, but the sum of all the drowned lands of the late Ice Age, the Doggerlands and Sunder Shelves, and Gulf oases that together formed a submerged world. When the sea rose, those worlds disappeared, and the collective memory of their loss condensed into one enduring story. There's something profoundly human in that condensation. We simplify the incomprehensible into a single image, a single name. Atlantis stands for every vanished shore, every forgotten village, every drowned field. It is both myth and metaphor for the fragility of progress. Plato used it to warn that arrogance leads to ruin, but the myth's deeper power lies in its melancholy, its recognition that nothing, no matter how advanced, can resist the patience of the sea. Modern archaeology, cautious as it must be, treats such stories as hints rather than evidence. But hints can be powerful. They can tell us where to look. In the case of the Black Sea flood, for instance, geologists William Ryan and Walter Pittman in the 1990s proposed that the sudden influx of Mediterranean water around 7,500 years ago could have inspired the flood myths of Mesopotamia and beyond. Their hypothesis remains debated, but it encouraged a generation of underwater research. Expeditions found ancient shorelines, river valleys, and even submerged settlements beneath the waves. The myth led the science, and science gave the myth a frame. This interplay between imagination and evidence is part of what makes the study of ancient floods so compelling. We stand at the intersection of two ways of knowing, one measured, one remembered. The scientific method demands proof, replication, and clarity. Myth operates on resonance. It survives because it feels true, not because it can be verified. Yet sometimes these two paths cross, and when they do, they illuminate each other. A core sample from the seabed, showing a sudden change in sediment, tells us that something massive happened. A story passed down for 5,000 years tells us what it felt like. Together they complete the picture. There's another layer to these stories, one that speaks to how humans understand time itself. In flood myths, time collapses. The ancient and the recent merge. A single flood becomes every flood. The story of loss becomes a framework for identity. People tell these tales not only to explain the past, but to prepare for the future. They teach that change is inevitable, that water always returns, that survival depends on humility. That lesson, once born from the memory of the last great melt, remains as relevant now as it was then. If the sea does hide traces of the first civilizations, those traces might be simpler than we imagine. Villages, fishing grounds, places of ritual. But the stories of their loss have outlived the ruins themselves. The ocean may erase stone, but it cannot erase memory so easily. The mind keeps what the earth forgets, passing it forward in the only durable medium we've ever truly mastered, storytelling. Each retelling adapts to its time, acquiring new meaning, but the core endures. The sea rose, the land vanished, people survived. That's the essence of almost every flood myth, stripped of divine punishment or moral lesson. It's not just a warning, it's a testimony. When we listen to these myths now, with the knowledge of geology behind us, they become something different. Not superstition, but history filtered through human experience. They remind us that science and myth are not rivals but partners, each recording what the other cannot. Science tells us how much the seas rose. Myth tells us how it felt to watch it happen. Both speak of loss, and both speak of continuity. The water came, but life went on. The flood ended, and people built again. Somewhere out there, beneath the calm blue surface, lie the places that gave birth to these memories. They're not grand cities, most likely, but quiet places. Fields, river mouths, fishing camps, where the first humans watched the horizon change. The ocean has kept them, sealed beneath layers of sand and time, while their stories floated upward into history. Each myth is a ripple from that hidden world, travelling across centuries to reach us. And as we drift with those ripples, it's hard not to feel that they're guiding us somewhere, toward the line where story ends and evidence begins, where memory meets the ocean floor. It's there, in the silence beneath the waves, that the next questions wait. The ones about what we've found, what we've mistaken, and how we can tell the difference between a story told by humans and one written by the earth itself. The search for what lies beneath the waves begins with patience. The ocean doesn't give up its secrets easily, and most of the time it doesn't give them up at all. But for the scientists who devote their lives to finding traces of the past under the sea, patience is part of the work. The ocean floor is not silent. It is simply speaking a language of echoes, textures, and chemistry that takes time to learn. When we talk about the science of submerged ruins, what we're really talking about is how we've begun to translate that language, one sonar ping and sediment sample at a time. The first thing to understand is that underwater archaeology is not a branch of land archaeology that just happens to be wetter. It's an entirely different environment with its own rules, limitations, and discoveries. On land, a site remains visible. Layers of soil can be brushed away with care, revealing structures in sequence. Underwater, everything is in motion. Sand shifts, currents rearrange artifacts, corrosion changes surfaces beyond recognition. Even light behaves differently, scattering and dimming so that visibility can drop to a few meters. In this world, archaeologists don't dig, they listen. To map what they cannot see, they use sound. Sonar, short for sound navigation and ranging, works by sending acoustic pulses through water and measuring the echoes that return. Different materials reflect sound differently. Rock sends back a sharp signal, mud gives a dull one. Metal sings briefly before fading. By scanning systematically, scientists build detailed images of the seafloor. Multi-beam sonar, one of the most common tools, emits hundreds of narrow sound beams at once, creating wide swathes of data that can be stitched together into topographic maps. What emerges are shapes and contours, ridges, terraces, straight lines that might be natural formations or something else entirely. When something interesting appears, a regular pattern, a series of geometric lines, or an anomaly that doesn't fit the surrounding landscape, researchers deploy remotely operated vehicles or ROVs. These machines, tethered to ships above, can descend hundreds or even thousands of meters, carrying cameras, lights, and manipulators. They glide slowly, scanning the seabed with steady precision, like cautious explorers tracing shadows. Some of the images they send back look mundane, just rocks and sediment. Others reveal something that makes even seasoned scientists pause. Rows of stones too evenly spaced, platforms carved at right angles, stare like terraces that seem to belong to another time. Take, for example, the Yonaguni Monument off Japan's Ryukyu Islands. Discovered by a local diver in the 1980s, it lies about 25 meters below the surface. It's a massive formation, roughly the size of a football field, with steps, terraces, and flat surfaces that appear unnaturally straight. Some sections look like walls, others like platforms. When images of it first surfaced, they caused a storm of debate. Some researchers argued it was a natural sandstone formation, shaped by tectonic fractures and wave erosion. Others saw in it the remnants of human construction, an ancient complex built before the sea rose. The truth remains uncertain, but the monument sparked a new wave of interest in underwater structures. pushing scientists to refine their methods and technology. Natural or not, sites like Yonaguni remind us that the line between geology and archaeology is often thin. Nature builds as cleverly as humans do. Basalt columns can look like streets. Coral can mimic walls. Erosion can carve stairs more neatly than any mason. To tell the difference, researchers look for subtle signs, patterns that repeat, orientations that align to cardinal directions, marks of tool use, or the presence of artifacts nearby. The ocean complicates all of this by moving things around. A stone tool might travel miles from where it was dropped. A pottery shard might settle on an older structure, confusing the timeline. Each clue must be weighed, tested, and placed within the context of everything else the site reveals. Sonar and ROVs are only the beginning. Newer techniques push the boundaries of what we can detect. Sub-bottom profilers send low-frequency sound waves deep into sediment layers, creating cross-sectional images that reveal buried structures or old riverbeds. Side-scan sonar, which paints acoustic images of the seafloor, can show the outlines of roads, walls, or shipwrecks. LiDAR, used from aircraft or drones in shallow waters, measures the reflection of laser pulses to create high-resolution maps that reveal features invisible to the naked eye. Then there's the chemistry. Sediment cores, cylindrical samples extracted from the ocean floor, act as time capsules. Layer by layer, they record changes in environment, from fresh water to salt water, from river delta to open sea. A sudden spike in organic carbon might indicate human activity. Microscopic charcoal could signal fires. Traces of pollen tell scientists what kinds of plants once grew nearby, helping reconstruct the landscape before it drowned. By dating these layers through radiocarbon analysis, researchers can build precise timelines. In some cases, even DNA can help. Sediments preserve fragments of environmental DNA, microscopic genetic material shed by organisms into their surroundings. By sequencing these traces, scientists can identify what species lived in a particular place thousands of years ago. If marine DNA suddenly appears in a layer that previously held terrestrial life, it means the sea arrived at that level. In this way, genetics becomes a tool not just for studying life, but for mapping the changing face of the planet. When these techniques come together, they form a kind of forensic science of time. A sonar image shows the shape of the past. A sediment core tells the sequence of events. DNA and chemical traces fill in the texture of life that once existed there. Piece by piece, the picture sharpens. Sometimes it reveals the mundane, an ancient river channel, a natural ridge. But sometimes it shows something unmistakably deliberate. Stones arranged in circles, hearths filled with charcoal, tools lying where they fell. These are the quiet moments when science touches the edge of myth, when what was once a story whispered through generations becomes something you can hold in your hand. In the Mediterranean, such moments have already occurred. Off the coast of Israel lies Atlit Yam, a Neolithic village submerged about 10 meters underwater. Discovered in the 1980s, it dates back nearly 9,000 years. Divers found stone houses, wells, tools, and even the remains of human skeletons preserved in the silt. At the centre of the site stood a circle of standing stones, perhaps for ritual use. Everything was frozen in place, as if the inhabitants had simply left one day and never returned. Geological studies show that rising sea levels gradually flooded the area, turning it into part of the ocean. For archaeologists, Atlit Yam is proof that entire communities once thrived where the sea now lies. It's a tangible link between legend and reality, showing how easily civilizations can slip beneath the waves. Further east in the Gulf of Kambat off India's coast, sonar surveys have revealed geometric patterns extending for kilometers under the seabed. Some researchers interpret them as possible ruins. Others caution that they may be natural. The challenge lies in access. The waters are murky, the current strong, and the sediment thick. But the region's history is compelling. The nearby Indus Valley civilization flourished along rivers that once extended far beyond their modern mouths, suggesting that earlier settlements may lie buried offshore. Each expedition returns with fragments, pottery shards, carved stones, pieces of wood carbon dated to 10,000 years ago, but none yet conclusive. The search continues, steady and methodical, because the ocean's memory demands repetition before it yields answers. Off Malta, divers have documented underwater structures that resemble megalithic temples similar to those found on land. In Greece, near Pavlopetri, one of the oldest known submerged towns lies just a few meters below the surface. Pavlopetri dates back around 5,000 years and includes streets, courtyards, and tombs. Its preservation is remarkable, a combination of luck and geology. The seabed there is stable, and the sand covered the ruins gently, sealing them away. Sites like this demonstrate how thin the boundary is between land and sea, and how easily human history can slip from one to the other. The Mediterranean holds hundreds of similar sites, many still being catalogued. Ancient ports, shipyards and harbours lie scattered along its coasts, reminders that humans have always built close to water. For every known site, countless others likely lie deeper, where the continental shelves drop away. Modern technology is finally making it possible to explore these depths systematically. Autonomous underwater vehicles, equipped with AI-driven sensors, can now scan vast areas autonomously, identifying anomalies with precision that would have been impossible a generation ago. What was once guesswork is becoming data. Yet, even as our tools grow more sophisticated, the interpretation remains an art as much as a science. The ocean doesn't preserve neatly. A ruin might look pristine in one place, and eroded to nothing a few meters away. Layers of sediment might compress artifacts from different ages into the same stratum. To understand such complexity, scientists collaborate across disciplines. Geologists, oceanographers, archaeologists, chemists and engineers, all working together to reconstruct not just what lies beneath, but how it got there. Sometimes the results are humbling. Sites once thought to be ancient cities turn out to be natural formations. Others, dismissed as random rock piles, reveal under careful analysis the telltale symmetry of human design. Science advances through correction as much as discovery. The ocean, in this sense, teaches humility. It reminds us that certainty is rare and that even the clearest image can be misleading. But it also rewards persistence. Each confirmed site expands the map of human history, pushing the timeline of settlement and culture a little further back. Each find proves that people lived closer to the changing sea than we once thought possible. Even small discoveries, a hearth, a fragment of tool, a wall foundation, add to a growing understanding that early humans were not merely nomads chasing food. They were builders, engineers, and observers who adapted to their environments with remarkable skill. The science of submerged ruins also forces us to rethink what we mean by civilization. We often define it by monumental architecture, pyramids, temples, palaces, but those are the survivors, not the beginnings. True civilization may have started in places that left no stone behind, where communities first settled long enough to develop memory, ritual, and continuity. If those places now lie underwater, then the ocean floor is not a graveyard but an archive of civilization's infancy. To study it is to accept frustration. Most expeditions return with more questions than answers. Equipment malfunctions, weather changes, currents bury what was exposed just weeks earlier. Funding runs out before surveys can finish, but each challenge underscores the scale of the task. The seafloor covers more than 2/3 of the planet, and less than a fraction of 1% has been explored in archaeological detail. That vastness is both daunting and exhilarating. For every disappointment, there's the awareness that something extraordinary could still be waiting, hidden beneath a thin layer of sand a few centimeters deep. Sometimes, discoveries happen by accident. A diver searching for shipwrecks stumbles upon ancient stone formations. A fishing trawler hauls up artifacts in its nets. A sonar scan meant for pipeline planning reveals the outline of a forgotten shoreline. Many of the most significant finds began this way, serendipity meeting curiosity. The ocean, though vast, occasionally rewards those who listen carefully. In recent years, even satellites have joined the search. Though they cannot see through water, they can detect subtle differences in sea colour and surface patterns that indicate underwater structures. Combined with sonar and bathymetric mapping, they create multi-layered reconstructions of ancient coastlines. Digital models can now simulate what these regions looked like before the flood. Scientists can walk virtually across landscapes that haven't existed above water for 10,000 years, tracing river valleys, lakes, and even the faint grid lines of possible human habitation. The deeper we look, the more we realise how incomplete our knowledge has been. The story of humanity did not begin in deserts or river valleys alone. It began wherever the boundary between land and sea offered life and movement. The ocean was not an obstacle. It was the first highway, the first source of abundance, the first mirror that showed us the changing world. The ruins we find beneath its surface are not isolated curiosities, but parts of that original network. They tell us that the beginnings of civilization were more widespread, more coastal, and more complex than we once imagined. What makes this exploration so mesmerizing is that it's as much about the present as the past. The same forces that drowned those ancient worlds are at work again. The same technologies used to study lost cities are being used to monitor modern coasts. Every sonar map of a submerged ruin is also a warning, a glimpse of what happens when the balance shifts. The sea has always been patient, but never still. For now, the scientists continue their quiet work, mapping, sampling, analysing, waiting for the next anomaly that might rewrite a small corner of history. They know the odds, but they also know the reward, the possibility of finding that one unmistakable sign of human intention carved into the ocean floor. A right angle where none should exist, a pattern too deliberate to be chance, a tool caught in stone that once was sure. And as the data accumulates, something subtler emerges, a sense that the ocean, in all its vast indifference, still carries our reflection. Every discovery beneath it is also a reminder of how easily our own cities could share the same fate. We are not the first to live at the edge of the tide, and we will not be the last. Beneath the waves, the machines keep searching, tracing the outlines of the lost walls, listening to the echo of history against the seafloor. The signals return, faint but steady, forming maps of things unseen. And with each one, we get a little closer to understanding how memory endures even when the world forgets, how ruins can persist beneath centuries of water, and how, perhaps, the next story waiting to rise from the depths is already whispering through the static of sonar, just waiting for someone patient enough to listen. Proof is a fragile thing. It's not just about what we find, but about what manages to survive long enough to be found at all. The ocean doesn't care about our need for evidence, or our hunger to confirm old suspicions. It buries, corrodes, dissolves, and rebuilds in cycles of endless patience. What we call discovery often depends on coincidence. A gap in sediment, a current that shifts just enough to uncover something, a moment when light or sonar happens to touch the right place. For every artifact that makes it into a museum, there are countless others scattered, broken, and erased before anyone even knew they existed. The sea's memory is deep, but its archives are fragile. When archaeologists study ancient remains on land, they already fight against time. Wind, rain, temperature, and bacteria conspire to strip away the record of life. Underwater, the challenge multiplies. Salt water accelerates decay. Wood dissolves. Metal corrodes into dust. Bones crumble under the slow pressure of silt. Even stone, which we imagine as eternal, loses its edges. its carvings smoothed by the slow abrasion of sand and current. What remains after millennia under the sea is rarely recognizable as human work. A carved block becomes a rounded boulder. A wall collapses and becomes a natural ridge. The ocean's slow motion is an eraser that never stops moving. To preserve something underwater requires a perfect balance of circumstances. The site must be buried quickly enough to shield it from oxygen and microbes, yet not so deeply that geological processes destroy it. It must escape the attention of storms, currents, and tectonic shifts. It must exist in water cold enough or still enough to slow decay. That combination is rare. When it happens, the results can be astonishing. Shipwrecks nearly intact, villages preserved under layers of sediment, even human remains fossilized in anaerobic mud. But these are exceptions. For the most part, what lies beneath the waves is silence. The science of proof in this environment is delicate because absence doesn't mean non-existence. A missing artifact doesn't prove there was nothing to find. It might simply have vanished beyond recovery. This is the paradox of underwater archaeology. The ocean hides as much as it reveals, and sometimes it hides too well. Researchers are left with fragments, tiny pieces of wood, flakes of obsidian, scattered bones, and must build entire worlds from them. Interpretation becomes an act of balance between skepticism and imagination. One step too far in either direction, and the story collapses. Take, for instance, the ongoing debates about early coastal settlements. When sonar images reveal patterns that look geometric, it's tempting to call them ruins. But without direct evidence, tools, pottery, or artifacts, the conclusion remains uncertain. The ocean is full of illusions. Basalt fractures can form perfectly straight lines. Sand ripples can mimic roads. Coral growth can imitate columns. For proof, scientists need context, multiple signs that point in the same direction. Yet, the same forces that might create that context often destroy it. A current that exposes a structure also washes away the artifacts that would have confirmed it. Proof becomes not only rare but self-erasing. The problem extends beyond the ocean floor itself. Even the act of searching can disturb the very thing being studied. A remotely operated vehicle with its thrusters and lights stirs up clouds of silt that can take hours to settle. A diver's fin can scatter delicate deposits that took millennia to form. The first glimpse of a site can also be its last because once exposed it begins to decay faster. Archaeologists know this well. They document obsessively because the moment of discovery often marks the beginning of a loss. In underwater research, proof is an event measured in seconds. That fragility shapes the entire field. Many underwater sites are studied not directly, but through images, sonar maps, and sediment samples. The physical artifacts remain untouched, protected beneath their layers, because to reach them would be to destroy the conditions that have kept them safe. The ocean, in this sense, acts like both a vault and a trap. It preserves what it buries but punishes intrusion. Scientists learn to read traces, to work with inference and probability rather than certainty. It's a different kind of knowledge, less about possession and more about recognition. Sometimes proof takes the form of absence itself. When sediment cores show a sudden transition from freshwater to saltwater species, it proves that the sea invaded what was once land. When pollen disappears from a layer, it tells of forest drowned. When isotopic ratios shift, it records a flood no human ever witnessed. The ocean leaves signatures in chemistry, even when it leaves no artifacts. These are forms of proof too. Less tangible, but no less real. They remind us that history can be written in atoms as well as in stone. There's also the human side of fragility. Interpretation is not immune to bias. The desire to find something extraordinary can lead even careful scientists to overstate what the evidence shows. The history of underwater exploration is full of hopeful mistakes. Natural formations hailed as lost cities, coincidental alignments declared intentional. Each claim invites scrutiny, each discovery demands replication, and the process takes years. In the end, most sensational finds fade quietly into the background of geology, while a few, more modest ones, stand the test of rigorous study. Real proof, like the structures at Pavlopetri or Atlit Yam, doesn't need grandeur. It only needs consistency. But that consistency takes time. Layers of analysis follow each other like tides. A site is mapped, then sampled, then dated, then modelled. Each step narrows the possibilities. Each brings its own uncertainties. Radiocarbon dating, for instance, depends on organic material surviving long enough to measure. In salt water, that's rare. Stone tools can't be dated directly. Scientists rely on the context around them, the sediment, the shell fragments, the mineral deposits that form afterward. Each of those can shift over time, introducing doubt. Proof, in this world, is not a single piece of evidence, but a network of probabilities woven together carefully enough to hold. Even when proof survives, it doesn't always tell a clear story. A wall can mean many things. It might be a foundation, a boundary, or a natural formation mistaken for both. A scatter of tools might indicate habitation or simply a place where objects were lost. The human urge to find pattern in chaos can mislead as easily as it guides. That's why the most experienced underwater archaeologists speak not of discovering civilizations but of investigating possibilities. Their language is cautious, respectful of the ocean's ability to deceive. The fragility of proof also reflects the fragility of memory itself. Just as physical traces fade, so do the stories that accompany them. Oral traditions preserve much, but they too evolve. A flood becomes a divine act. A vanished land becomes a kingdom, and over centuries the details that might have once been evidence blur into symbolism. When myth and geology meet, the overlap is tantalizing but uncertain. Science can confirm that floods happened, but it cannot prove that a specific story describes one of them. The connection between evidence and experience remains an unbridgeable gap. Proof dissolves not only in salt water, but in time. Sometimes, the absence of proof can be as revealing as its presence. In the Persian Gulf, for example, geologists have mapped what was once a fertile valley system. Satellite and sonar data show ancient riverbeds now deep beneath the sea, suggesting that the area could have supported early human life. Yet despite years of searching, no artifacts have been found. Does that mean no one lived there? Probably not. It may simply mean the ocean has already consumed whatever they left behind. The same goes for the Sunda Shelf and the Bering Land Bridge, regions that were likely corridors of human migration and settlement, now erased beyond recognition. Their emptiness today is a reminder of how quickly time outpaces our ability to hold on. The process of decay underwater is not only mechanical but biological. Microbes feed on organic matter even in extreme conditions. Barnacles and corals colonize surfaces within weeks. Worms bore into bone and wood. Over centuries, these living agents of change dismantle structures molecule by molecule. They are nature's archivists and destroyers at once. By the time we arrive, what remains is often a composite of the natural and the artificial, a ruin made partly by humans and partly by the sea. The boundary between the two becomes impossible to draw. In the face of such fragility, the very concept of proof begins to shift. It becomes less about finding absolute confirmation, and more about building a coherent story from partial evidence. The scientist learns to live with uncertainty, to let patterns emerge from fragments. The process resembles memory itself, never complete, always reconstructive, always shaped by what's missing as much as by what's found. Proof becomes a kind of conversation between presence and absence. Every field expedition ends with the same paradox. The researchers return to shore with boxes of samples, drives full of sonar data, and hours of footage. They have seen structures that seem deliberate, patterns that seem human, but when they present their findings, the first question is always the same. How can you be sure? And the honest answer, the only one possible in a world this mutable, is that certainty is rare. The ocean is not a museum. It is a living system, constantly remaking itself. The best we can do is gather enough evidence to make a strong case, to say that this alignment, this layer, this anomaly, could not have formed by chance alone. Even then, doubt lingers, as it should. That doubt, however, is not defeat. It's what keeps the search alive. The fragility of proof ensures that curiosity never ends. Each unanswered question leads to another dive, another scan, another attempt to read the seafloor's shifting script. The ocean, in its quiet indifference, forces us to earn every revelation. And perhaps that's why the discoveries, when they come, feel so profound. A single intact wall beneath 10 meters of water carries the weight of centuries. A shard of pottery emerging from silt can rewrite the map of early human migration. Proof may be fragile, but its impact is immense. There's a quiet irony in how we measure significance. A single artifact on land might be a footnote. Underwater, it can redefine history. The rarity of survival amplifies its value. Scientists know this, and they tread carefully. They photograph before they touch, document before they move, analyze before they interpret. Every action risks destroying the very thing they hope to preserve. In that caution lies a kind of reverence, not for the artifact itself, but for the process of knowing. And still, even with all this care, the ocean continues its slow work of forgetting. New sediments settle over old sites. Coral grows, currents shift. The proof we find today may vanish again tomorrow, covered once more by the endless motion of water and time. The record we build is temporary, a snapshot in a cycle that never ends. That awareness shapes the mindset of those who study it. They don't aim to conquer the mystery, only to glimpse it before it moves on. In the end, the fragility of proof is also its beauty. It mirrors the fragility of everything else we value: life, memory, civilization itself. What endures is not the material but the effort to understand. Each expedition, each fragment, each careful measurement is an act of defiance against forgetting. The sea may reclaim the ruins, but the knowledge we extract from them changes us. It deepens our sense of time, our respect for impermanence, our awareness of how little we can truly keep. And as we drift deeper into this thought, we can almost see the next layer forming. The idea that maybe proof doesn't need to be perfect to matter. Maybe the fragments are enough. Maybe what survives, however incomplete, tells us precisely what we're meant to know. That the ocean has always been both destroyer and guardian. That every ruin beneath its surface is a reminder not of what we've lost, but of how much there is still to find. And in that slow, endless search, the water keeps its calm, waiting for the next question to be asked, and for the next small piece of truth to emerge from the silt. If there were people who built before the known beginning, they did so in a world we can barely imagine. A world half frozen and half awakening, where mammoths still roam the plains, and the stars above look the same, but the coastlines below are unrecognizable. The idea that humans may have built, organized and created complex societies before the rise of Egypt, Sumer, or the Indus Valley isn't a matter of fantasy. It's a question of scale. We have existed as anatomically modern humans for at least 300,000 years, yet the record of what we call civilization covers only the last 5,000. That gap, enormous and silent, invites the simplest question imaginable. What were we doing all that time? To think of the first builders is to step into that silence. It doesn't require imagining vast empires or impossible technologies. It requires only imagining people, curious, social, inventive, living in environments now lost to the sea. They had fire, language and tools. They shaped stone, bone and wood. They buried their dead with care. They painted walls and carved figures. They observed the cycles of the sun and the moon. These are not signs of ignorance. They are signs of continuity. Civilization did not begin with invention. It began with memory, with the act of preserving what came before. When we look for traces of those early builders, we tend to look for scale, walls, monuments, architecture. But the first true constructions were smaller, subtler. A hearth built to last through a season, a storage pit lined with stone, a dam across a stream. The threshold between a temporary camp and a permanent settlement is thin. Once people stayed long enough to shape the landscape intentionally, they became builders. The problem is that wood and mud don't survive 10,000 years underwater. Only stone remembers, and even stone forgets eventually. Still, there are hints, scattered, stubborn, and strange enough to keep the question alive. In Turkey, far from any coast, lies Göbekli Tepe, a site that shouldn't exist according to traditional timelines. It was built around 11,000 years ago, long before agriculture or cities were supposed to appear. Massive T-shaped pillars, carved with intricate animal figures, form circular enclosures arranged with geometric precision. Whoever built it understood engineering, astronomy, and ritual. They organised labour, planned architecture, and left behind art that still stuns the modern eye. No one knows who they were, or why they buried the site themselves after centuries of use. What we do know is that their existence pushes the beginning of complex construction back several millennia. If such sophistication existed inland, why not on the coasts that have since vanished? The builders of Göbekli Tepe lived near the end of the Ice Age, when sea levels were still lower and the climate was unstable. If groups like them thrived along the rich, temperate coastlines of that era, the evidence of their settlements now lies underwater. Those areas would have offered abundant food, fish, shellfish, fertile plains, and rivers flowing to the sea. The transition from foraging to farming may have happened there first, on the now submerged shelves of the world. The first domesticated grains might have grown near ancient estuaries, the first temples built within sight of a shoreline that no longer exists. When the waters rose, they took not only land, but perhaps the first pages of civilization's story. The idea that humans built before the known dawn of history has always been controversial, partly because it challenges our comfort with progress as a straight line. We like to believe that development moved step by step, from stone tools to cities, from ignorance to knowledge. But geology tells a different story, one of cycles, interruptions, and losses. The Earth resets itself regularly. Climate changes, continents shift, and coastlines drown. Civilizations could have risen and fallen many times without leaving a trace we can still read. To imagine a forgotten chapter isn't to invent fantasy. It's to recognise how incomplete the surviving record truly is. Consider what we know of early human capability. By 50,000 years ago, our ancestors were already making composite tools, sewing clothing, and creating art. They built boats capable of crossing significant distances. Reaching Australia, for example, required navigating open sea. They traded obsidian and shells across hundreds of kilometres. These are not the actions of simple nomads. They show planning, cooperation, and an understanding of geography. It's not difficult to imagine that somewhere, in a favourable climate, such groups settled long enough to experiment with permanent structures. Perhaps they learned to shape stone into dwellings. Perhaps they organised rituals, built gathering spaces, and began forming the social hierarchies that define civilization. Most of the places where this could have happened are now drowned. The continental shelves, the zones that were exposed during the last ice age, account for some of the most habitable regions on Earth. Gentle slopes, fresh water, mild temperatures, abundant resources. If any early complex societies existed, this is where they would have thrived. The challenge is that the ocean covers their remains beneath hundreds of meters of water and thousands of years of sediment. What we can access represents only a fraction of what once existed. Archaeologists have found tantalizing evidence along these margins. Off the coast of India, submerged structures in the Gulf of Kambat suggest deliberate construction dating back to around 9,000 years ago, Near the coast of Japan, the Yonaguni monument, whether natural or human-made, indicates at least an awareness of the sea's encroachment. In the Mediterranean, Pavla Petri and Atlit Yam demonstrate that coastal settlements capable of architecture existed earlier than we once thought possible. Each discovery shifts the boundary of what's plausible a little further back. The question isn't whether humans could have built before recorded history. They clearly could. It's whether they did so in ways complex enough to count as civilization. That word carries assumptions. Cities, writing, governance, agriculture, religion. But perhaps we should think in different terms. A civilization doesn't have to mean empire. It can mean continuity, shared identity, collective effort. A community that gathered to build, to worship, to trade, and to tell stories about its origins was already laying the foundation for everything that followed. The first builders may have been more communal than monumental, more practical than grand. If we accept that possibility, then the lack of monumental ruins underwater makes sense. These early societies may have left traces too subtle for us to recognize. Terraces cut into rock, small shrines, harbours, or irrigation systems now obscured by coral. Their architecture might have been perishable. Wood frameworks, thatch, mud, and bone. The sea erases such materials completely. What remains are the stone tools and carvings that resist time's pressure. When those are found, far from known sites, they raise questions that standard timelines can't easily answer. The story of the first builders might also be one of migration. As the climate warmed, human populations expanded northward and along coastlines, following game and vegetation. These migrations weren't chaotic wanderings. They were guided by memory and observation. People returned to the same sites season after season, improving shelters, marking routes, leaving signs for others. Over generations, these temporary camps became semi-permanent and eventually permanent. The builders weren't starting from nothing. They were continuing patterns refined over tens of thousands of years. Civilization may not have begun with invention, but with persistence. There's a kind of humility in this realization. It reminds us that progress isn't inevitable or linear. It's fragile, dependent on geography, climate, and chance. If sea levels had remained stable, we might trace civilization back twice as far as we do now. But instead, nature edited the record. Whole epochs of human life were buried under the ocean's rewriting. The Earth didn't erase us out of malice. It simply kept moving, as it always has. For scientists trying to find proof of those first builders, the difficulty lies in distinguishing human design from natural form. The ocean sculpts with remarkable precision. Erosion, sedimentation, and biological growth can mimic intentional structures. To prove otherwise requires context, artifacts, stratigraphy, datable organic material. Without those, even the most convincing pattern remains uncertain. And yet, every few years, new evidence surfaces that keeps the question open. A hearth, preserved under sediment, a worked stone tool found miles offshore, pollen from cultivated plants beneath marine deposits. Each clue, isolated though it may be, points toward a deeper story still hidden beneath the sea. The search for these beginnings has become a discipline of patience. Geologists map ancient coastlines, identifying areas that would have been habitable. Oceanographers study currents and sedimentation rates to predict where traces might survive. Archaeologists deploy sonar and submersibles, scanning for anomalies that break the natural rhythm of the seafloor. It's a global effort, spanning from the North Sea to the Indian Ocean, from the Mediterranean to the Caribbean. The discoveries may be scattered, but their pattern suggests something larger. Humans were everywhere, building, adapting, and watching the waters rise. There's a quiet satisfaction in imagining those early builders at work. Picture them, on a morning long before the pyramids, shaping stones to fit together more closely than chance would allow. They might not have thought of themselves as architects. They were simply making a place to belong. Their tools were simple, their methods slow, but their intention, permanence, was the same as ours. They too wanted their shelters to endure storms, their shrines to outlast memory. They too looked at the horizon and wondered if it would stay where it was. The fragility of their creations doesn't diminish their achievement. If anything, it magnifies it. To build in a world constantly changing, to carve something meant to last on a planet that forgets, is an act of defiance. Every wall, every hearth, every stone aligned with the stars was a statement against impermanence. Those statements are still out there, dissolved and scattered, but their spirit endures in us. We are still building, still measuring, still seeking continuity in a transient world. If the first builders left no grand monuments, they left something subtler, the impulse to shape the world in our image. That impulse survives in every structure we raise, every bridge, every tower. It's the same need that drove them to stack stones along a shore that no longer exists. We are their continuation, not their replacement. The materials have changed, but the desire remains. Some researchers have begun to speculate that the origins of symbolic architecture, temples, monuments, ceremonial spaces, might predate agriculture. That perhaps the need to gather and build together came first, and the need to settle and farm followed. If true, it means that construction was not a byproduct of civilization, but its catalyst. People built first, and civilization grew from that act. It would explain why places like Göbekli Tepe appeared before farming villages. The builders may have gathered seasonally, drawn together by ritual, cooperation and shared vision. They may have invented permanence before stability. If similar gatherings happened along the coasts now lost, the ocean holds their traces. Circular arrangements of stones, ritual enclosures, causeways linking islands. These might have been the first expressions of culture larger than the individual group. The ocean, in absorbing them, didn't end the story. It preserved it in its own way, storing the evidence until our tools became precise enough to look for it again. We often think of the ocean as a frontier, but for the first builders, it was home. It provided food, roots, and rhythm. It marked the boundary between the known and the unknown. To live beside it was to understand its moods, its tides, its generosity, and its power. When the sea began to rise, it wasn't an enemy but an inevitability. They adapted as long as they could, moving inland, rebuilding, watching their old sites disappear. The last generations who lived on those drowning coasts must have felt the strangeness of seeing the places where their ancestors had built vanish beneath the water. Their memories became the first myths of lost lands. Their ruins became the first mysteries of the deep. What remains for us now is the echo of that continuity. We look for patterns on sonar maps, for right angles in the sand, for the slightest suggestion of design. Each discovery, no matter how small, feels like a conversation across time. It tells us that humans have always built not just to live, but to remember. To leave something behind that says, we were here. And maybe, somewhere out there, beneath layers of silt and coral, one of those voices still waits to be heard. A wall carved by hand, a pathway leading nowhere, a stone circle arranged to face the sunrise of a world long gone. Proof might never be complete, but the evidence of intent is enough. The ocean keeps it, the earth forgets it, and we keep searching for it, following that ancient human instinct that began the moment someone placed one stone upon another and decided it should stay. As we drift further through this thought, the image sharpens just a little. The hands of those unknown builders, the sound of waves nearby, the sense that they already understood how temporary everything would be. They built anyway, not to defy the sea, but to leave a trace of themselves within it. The water rose, and their world changed. But the impulse they began has never stopped moving. It carries forward in us, in every structure and story, in every quiet question asked when we look toward the horizon and wonder what lies beneath. The planet has always been rewriting itself. It's easy to think of the Earth as a finished thing, as if continents are fixed and oceans permanent, but nothing here is truly still. Every grain of sand, every current of air, every mountain and trench is in motion, recording one story while erasing another. Over billions of years, the Earth has become a palimpsest, a layered manuscript written, scraped clean, and written over again, where traces of older words still linger beneath the new. What we see on the surface is just the latest version of the text. Beneath it, faint but enduring, are the erased histories of oceans, forests, species, and civilizations. The metaphor isn't poetic exaggeration, it's literal. The rocks beneath our feet are records. Sedimentary layers preserve the quiet accumulation of time, each one a page written by rivers, winds, and waves. Volcanic ash seals sudden moments of catastrophe. Fossils, mineral veins, and isotopes tell of climate and chemistry. The planet's crust is a living archive, though not one organised for our convenience. Reading it requires patience and translation, because the handwriting changes constantly. What begins as clear writing, mountain ranges, river systems, coastlines, eventually becomes smudged, folded, or erased by new forces. The result is a world that remembers everything but refuses to make it easy to read. Tectonic movement is the pen and eraser of this planetary script. Continents drift, collide, and separate with slow inevitability. Ocean basins open and close. Mountains rise, only to be ground down by wind and rain. The crust is recycled through subduction zones, where old seafloor disappears into the mantle and re-emerges as new land elsewhere. Even the oldest rocks we know, 4 billion years old, bear scars of that process, rewritten again and again. If we were to look for a permanent record of the planet's surface, we'd find that no such thing exists. The Earth doesn't keep archives, it edits them. That editing process is why proof of the first civilizations, or even earlier species, is so difficult to hold on to. The planet's surface may seem ancient to us, but to geology it's temporary. The oldest seafloor today is only about 200 million years old, a mere chapter compared to Earth's full age. Everything older has already been recycled. Even continents, though longer lived, lose their details over time. Rivers change course, glaciers scrape valleys clean, deserts shift, floods deposit new sediments that bury what came before. To study the planet's history is to work backward through overlapping revisions, trying to separate one handwriting from another. The palimpsest isn't only geological, it's biological too. Life writes its own layers into the planet. Every organism leaves traces, molecules, shells, bones, or chemical changes in the air and soil. Those traces become part of the rock record, tiny signatures of existence. The oxygen we breathe was written by ancient cyanobacteria billions of years ago, long before plants. The chalk cliffs of England are the compressed remains of microscopic plankton. The limestone under tropical islands began as coral reefs. Even coal and oil are the fossilized handwriting of forests and plankton, transformed by time into energy that fuels our civilization. The planet remembers everything that lives upon it, though it often hides the evidence deep below. When humans arrived, our writing on this global manuscript became faster, louder, and harder to erase. Agriculture changed soils, cities compacted layers of earth. Mining and construction rearranged entire landscapes. In just a few thousand years, a blink in geological time, we have added a dense, unmistakable layer of our own. Scientists call it the Anthropocene, a proposed epoch marked by our influence on climate, biodiversity, and sediment. Future geologists, if any exist, will recognize it instantly. A thin line rich in plastics, concrete, and carbon isotopes. It's our signature in the palimpsest, our addition to a text that began long before we appeared. But before we began to write our own layer, countless others were already there. The drowned coastlines of the Ice Age, the vanished valleys of Doggerland, the sunken plains of the Sunda Shelf, all are part of the most recent chapter. Beneath them lie older stories, carved by rivers that no longer flow, shaped by species that no longer exist. If we could peel back each layer in sequence, we'd see the Earth transforming through stages of fire, ice, and flood. Cities would fade into forests, forests into deserts, and deserts into seas. Each cycle would reveal another civilization, not always human, but always alive. To call the planet a palimpsest is also to admit that much of what it writes is illegible to us. We can measure isotopes, scan subsurface structures, and date minerals, but we can never reconstruct everything. Too much has been rewritten. The crust that once held the first oceans is gone. The seabeds that recorded the rise of the earliest life have been consumed by the mantle. Even the fossils we recover represent only a tiny fraction of all that ever lived. The planet keeps its secrets by design, through motion. For underwater archaeologists and geologists alike, this presents both a challenge and a comfort. The challenge is obvious. How can we find what has been erased? The comfort lies in understanding that nothing is ever truly lost. Every atom of the past remains somewhere, transformed but still present. The carbon in ancient forests circulates through our atmosphere. The calcium from shells becomes limestone, then marble, then dust. Even the traces of lost civilizations, whether built or imagined, contribute to the chemistry of the modern ocean. The sea is the great blender of time, turning ruins into nutrients, stories into sediment. Sometimes, the planet's revisions overlap in ways that confuse even the most careful readers. A mountain ridge might contain rocks that once formed on the seafloor. A desert might hide beneath it the remains of a lush tropical swamp. The Sahara, for example, has alternated between arid dunes and green savanna many times. Beneath its sands lie fossilized river channels and ancient lake beds. Satellite imaging reveals the outlines of vanished deltas, showing that the desert we see now was once a cradle of life. When climates shift again, it may be so once more. The palimpsest continues to write. The oceans too have changed shape countless times. The Atlantic is a relatively young sea, born when Pangaea split apart. The Tethys, which once stretched between Africa and Asia, has long since vanished, its remnants forming the Mediterranean, Black and Caspian seas. Each transition buried shorelines, reefs and islands that once teemed with life. If civilizations ever rose before the ones we know, they might have done so on continents that no longer exist in any recognizable form. Their foundations could now lie kilometers beneath new crust, their materials melted and remade into something else entirely. The Earth doesn't merely bury its past, it recycles it, and yet some traces persist stubbornly. Zircon crystals older than 4 billion years, found in the rocks of Australia, preserve the memory of the planet's earliest crust. Microfossils in Greenland tell of life when the oceans were still forming. Magnetic patterns frozen into basalt record the shifting poles. These are the faintest of echoes, but they remind us that the planet, though constantly changing, never forgets completely. Even in erasure, it leaves outlines. Even in destruction, it builds continuity. Human history sits on top of that immense archive like a thin coat of paint on an ancient wall. Beneath our cities are layers of older ones. Beneath those, layers of prehistory. The process of excavation, whether in a desert or under the sea, is really a dialogue between timescales. We uncover our own recent past while glimpsing the deeper transformations that made it possible. A Roman port built on a Greek foundation might rest on a prehistoric shore. That shore might once have been a coral reef, which grew atop volcanic rock formed by an eruption millions of years earlier. Each layer adds a chapter, but no layer stands alone. Understanding Earth as a palimpsest also changes how we think about permanence. We build monuments believing they will last forever, but geology suggests otherwise. Even the strongest stone succumbs eventually. Earthquakes crack foundations, wind scours surfaces, tectonics lift and fold, turning cities into fossils. The pyramids and the Great Wall are geological blinks compared to the mountains and valleys around them. In time, they too will become part of the rock record, a human stratum pressed between others. From a distance of millions of years, they'll look no different from any other pattern of mineral and sediment. The distinction between natural and artificial fades with time. It's humbling to realize that the planet itself might have done this before. If an earlier civilization existed, human or otherwise, it would have left its mark in the same way. A brief pattern in the sediment, a chemical trace, an anomaly in the rock. But the longer the time since its disappearance, the fainter that mark becomes. Given enough millions of years, even concrete returns to dust, steel reverts to ore, glass becomes sand. The only record left would be in the isotopes and minerals formed by industrial processes, subtle but measurable. Some scientists have wondered whether, if Earth once hosted a pre-human civilization millions of years ago, we could even tell. The answer, most agree, is uncertain. We might never know. The planet's rewriting is too complete. This doesn't make the search meaningless. On the contrary, it gives it depth. To study the layers of the Earth is to participate in its memory, to add our curiosity to its ongoing revisions. Each core sample, each sonar scan, each excavation is a conversation with the past, an attempt to decipher the faded script beneath the newer lines. Even when we can't translate it perfectly, we learn something about how the text is written. We learn that time doesn't flow smoothly but folds, creases and loops back on itself. We learn that everything temporary is part of a larger continuity. There's something almost alive about this process. The Earth behaves less like a machine and more like an organism, growing, healing, forgetting and adapting. Its surface renews itself the way skin does, constantly shedding old cells to make way for new ones. The scars of impact craters fade, the marks of rivers shift, and the continents drift like slow muscles. To live on this planet is to live on something that is always in the act of becoming. The past isn't behind us, it's beneath us, layered invisibly under our feet. In that sense, the ocean is the most revealing layer of all. It's both the newest and the oldest part of the planet's surface. Its floor is young, yet its waters have cycled through the same basins for billions of years. Each drop of seawater has carried the dust of mountains, the ashes of volcanoes, the minerals of bones. When we search for ruins beneath the sea, we're not just looking for architecture, we're reading the latest revision of the Earth's story. Each submerged site, whether natural or human-made, is a phrase in that long text, written in the alphabet of currents and sediment. To view the planet this way, layered, dynamic, self-editing, is to understand that loss is part of its nature. The ruins we can no longer find are not missing. They've been rewritten. Their materials are still here, transformed into new landscapes, new ecosystems, perhaps even new civilizations. The same calcium from ancient shells now forms the limestone under our cities. The same silica from prehistoric sands is in our glass. The past is never truly gone, it's simply rearranged. This realization softens the boundary between science and imagination. When we wonder about the first civilizations, we're not just speculating, we're participating in the planet's ongoing act of remembering. Our questions are part of the next layer, etched into the geological record as data, stories, and thought. Future beings might study our remains as we study the fossils of ammonites or the stones of lost temples. They'll see that we too were builders and dreamers, trying to understand the layers beneath us before they became part of us. The Earth as a palimpsest reminds us that knowledge itself is provisional. Every generation rewrites what it knows based on what it discovers. The same is true of the planet. Its landscapes are revisions, not originals. The continents are drafts. The mountains are annotations. The oceans are erasures filled with new text. We live in the margin between what's visible and what's forgotten, and as we drift through that awareness, it becomes easier to imagine how this same planet once looked entirely different, how other coasts, other rivers, other worlds may have existed before ours. The sea that now conceals their ruins is still writing over them, adding its latest sentences of coral, silt, and life. Somewhere, beneath those layers, the handwriting of the first builders remains faintly visible, waiting for us to notice the texture beneath the ink. The page keeps being written, the planet keeps revising, and we, for now, are just one more line in its story, a brief mark that will one day fade into the next layer of the Earth's unending script. The effort to uncover the planet's erased history depends on a new kind of craftsmanship. Tools not made of stone or bronze, but of sound, light, magnetism, and data. The same human instinct that once drove the first builders to shape stone now drives scientists to reshape understanding. Every instrument they use is, in its own way, an extension of curiosity. The tools of rediscovery don't merely find, they translate. They turn invisible landscapes into maps, traces into patterns, silence into information. It starts with sound. The ocean is opaque to light, but sound travels through it with remarkable clarity. That simple fact has made sonar the first and most essential tool of underwater exploration. Ships crossing the sea send out pulses that bounce off the seafloor and return as echoes. The time it takes for those echoes to come back reveals depth, while the strength of the signal reveals texture. Modern multi-beam sonar arrays send out hundreds of beams at once, painting wide swathes of seafloor in three-dimensional relief. The data, when processed, becomes a landscape. Ridges, valleys, shelves, and plains rendered in ghostly shades of blue and grey. These maps are astonishing, not only for their precision, but for their reach. Vast portions of the ocean that were once unknown now have contour, shape, and form. Submerged river systems, ancient deltas, and the outlines of lost coastlines appear like photographs developing in slow motion. In the North Sea, sonar surveys have traced the channels of Doggerland's rivers in detail, showing where humans once fished and hunted. In Southeast Asia, the submerged valleys of the Sunda Shelf have been mapped so clearly that researchers can reconstruct the flow of water across the vanished plains. In these images, the landscape of 10,000 years ago comes back into view, not imagined, but measured. But sonar alone can only show shape, not age. To understand when and how those shapes formed, scientists rely on another set of instruments. Sediment corers extract long, narrow samples from the seabed, each a vertical timeline of deposition. The layers inside tell stories of changing environments, grains of river sand giving way to marine silt, freshwater shells replaced by saltwater species. The transition marks the moment when the sea arrived. Radiocarbon dating of organic material, wood fragments, pollen, shells, pinpoints the timeline. These cores allow scientists to connect specific geological events to broader patterns of climate change and sea level rise. They are, quite literally, the stratigraphy of memory. Technology has turned this process into a discipline of extraordinary precision. Cores only a few centimetres in diameter can record thousands of years of history. Their chemistry can reveal ancient temperatures, oxygen levels, and even the sources of erosion upstream. Computer models then use this data to simulate how coastlines advanced and retreated over time. What was once speculation becomes a dynamic reconstruction, showing the transformation of Earth's surface frame by frame. Sometimes these reconstructions lead to surprising results. In regions like the Persian Gulf, they've shown that the flooding of the ancient basin was slower and more complex than previously thought, leaving pockets of habitable land far longer than expected. In the Black Sea, they've revealed that the influx of Mediterranean water may have been gradual, not catastrophic. These nuances reshape not only geological history but human history as well. They affect where we look for settlements, how we interpret migration, and how we understand the resilience of early societies. Other instruments extend the search into dimensions we cannot sense directly. Magnetometers detect variations in the Earth's magnetic field, caused by differences in rock type or the presence of buried materials. A pattern of anomalies on the seafloor might indicate walls, foundations, or roads. Ground-penetrating radar, used in shallow water or along coastal plains, sends electromagnetic waves below the surface, mapping hidden structures without excavation. Together, these technologies allow researchers to see through layers of sediment, as if turning translucent pages in the planet's book. In shallower coastal areas, where sunlight still penetrates, LIDAR has become an invaluable tool. Short for light detection and ranging, it uses lasers mounted on aircraft or drones to measure precise distances to the surface below. When applied to clear water, LIDAR can reveal the contours of submerged terrain, even distinguishing stone walls or causeways beneath sand. Archaeologists have used it to find shipwrecks, harbour remains, and ancient roads lost to the tide. In one case, surveys along the Florida coast revealed complex networks of prehistoric canals built by indigenous peoples to manage water flow and trade. What the eye can't see, the laser can. But the greatest transformation in recent years has come from data itself. Every sonar scan, every sediment core, every image captured by remotely operated vehicles contributes to vast digital archives. These archives are layered much like the sediments they describe. Artificial intelligence now helps analyze them, spotting patterns too subtle or complex for human eyes to detect. Algorithms trained on known archaeological sites can identify similar formations elsewhere, guiding future expeditions. The ocean's surface becomes a searchable document, its secrets indexed in probability rather than myth. Even so, technology alone isn't enough. The ocean's data is noisy. Currents, temperature gradients, and biological life all distort readings. What looks like a wall might be a coral ridge. What looks like a road could be an artifact of resolution. Human intuition remains vital. The same curiosity that guided early explorers now helps interpret the flood of information from machines. Scientists learn to read sonar maps the way geologists read outcrops or linguists read dialects. Each anomaly becomes a word in a larger conversation between technology and interpretation. Among the most important tools in that conversation are remotely operated vehicles, or ROVs, and their autonomous counterparts, AUVs. These robotic explorers are the modern equivalent of diving bells, but far more capable. They move slowly and deliberately, carrying cameras, manipulators, sensors, and sometimes drills. Controlled from research vessels on the surface, they can hover above a suspected site, taking high-resolution photographs from multiple angles. Some can collect small samples for laboratory analysis, while others can map the terrain in centimetre-scale detail. Their cameras capture light that hasn't touched human eyes in thousands of years, and their sensors measure everything from temperature to magnetic fields. The imagery they return is haunting. Stone walls draped in algae, pottery half buried in sand, coral growing over what might once have been steps or foundations. Sometimes the scene is ambiguous, straddling the line between natural and human-made. Other times, it's unmistakably deliberate. A circle of stones, a carved surface, a straight edge aligned to a forgotten horizon. These images bring a stillness that words can't quite convey. A sense that time underwater behaves differently, stretching and slowing until millennia feel like a single moment. When artifacts are recovered, the process of rediscovery continues in laboratories. Each object must be desalinated carefully, otherwise salt crystals form inside and destroy it. Some artifacts are stabilized in chemical baths, others kept permanently in controlled humidity. What seems like a small find, a piece of wood, a bone, a tool, can take months to preserve. Specialists analyze isotopes, trace elements, and wear patterns, extracting information invisible to the naked eye. A single object can reveal trade routes, diets, technologies, even cultural connections across continents. What's remarkable is how the tools of rediscovery mirror the processes of forgetting they try to undo. The same way the ocean layers its sediment, researchers layer their data. Each pass of sonar adds a new coating of information. Each dive revisits the same place from a slightly different angle. Knowledge builds like coral, slowly, through accumulation. There are no sudden revelations, only gradual clarity. In this sense, rediscovery isn't about revelation, it's about persistence. Satellite technology adds yet another dimension. Though satellites can't see through water, they can measure subtle variations in sea surface height caused by gravitational differences beneath. A dense mass, like a submerged ridge or plateau, pulls slightly more strongly on the water above, creating tiny bumps measurable from space. These readings, combined with bathymetric data, reveal underwater mountain chains, plateaus and basins that might once have been land. In 2014, satellites helped confirm the shape of Zealandia, a nearly submerged continent beneath New Zealand, proof that entire land masses can hide in plain sight. For archaeologists, such findings are both humbling and inspiring. If a continent can vanish, what else might be waiting unseen? Even the chemistry of the sea itself has become a tool. Oceanographers analyze dissolved gases, isotopes and minerals to track changes in temperature and salinity over time. These patterns, when matched with sediment records, can pinpoint the timing of floods and glacial melts. In some cases, ancient DNA extracted from marine sediments, called cedar DNA, reveals the presence of species long extinct. This includes plants and animals from periods when the now submerged coasts were still dry land. Each strand of genetic material is a microscopic fossil, carrying echoes of ecosystems that vanished beneath rising tides. The scope of these tools is vast, but their goal is simple: to reconstruct lost worlds as faithfully as possible. They can't restore what the ocean has erased, but they can outline it, give it contour, bring it back into view long enough for us to imagine it clearly. That act of imagining is as important as the science itself. It connects us to the people who once lived there, to their choices, their fears, their ingenuity. Every sonar sweep and core sample is a bridge between our present and their vanished future. As the methods evolve, so does our understanding of time. The boundaries between archaeology, geology, and climatology blur. Studying a submerged settlement means studying the world around it, the climate that shaped it, the ocean that covered it, the tectonics that preserved or destroyed it. Rediscovery becomes interdisciplinary by necessity. Scientists, divers, historians, and engineers share data, each adding a layer to the composite image. No single tool reveals the whole. The picture emerges only when all are used together. There's a kind of quiet poetry in this collaboration. The machines hum and scan. The data accumulates silently in servers. On deck, researchers huddle over screens, watching grainy images drift upward through darkness. They may not know in that moment whether they're seeing something world-changing or simply another rock formation. But they keep watching because the possibility, the faint chance that the ocean is about to yield a new word in its long story, is enough. What drives this patience is not just scientific curiosity, but a deeper sense of continuity. Each discovery under the sea reminds us that our own civilizations, no matter how advanced, are temporary as well. The tools we use to study the drowned past may one day be used to study us. The same sonar that maps ancient coastlines might trace the outlines of our cities long after they're gone. The same satellites that measure the depth of forgotten seas might one day scan the ruins of our own shorelines. Rediscovery is not only backward-looking, it's rehearsal. In that sense, the tools of rediscovery are also tools of memory. They allow the planet to remember itself through us. Every image, every data set, every preserved artifact adds to the shared archive of what Earth has been. The ocean, indifferent though it is, becomes readable again, its surface less a barrier than a lens. The technology doesn't conquer the sea, it listens to it. It turns what was once the language of myth into something measurable, without stripping away its wonder. And so, the work continues. Ships sail slowly across the world's shelves, their instruments whispering through the depths. Computers hum with incoming data. divers and engineers prepare for the next descent. The ocean remains vast, the task endless, but the progress steady. With each new scan, each new layer of insight, the picture sharpens a little more. The lost shorelines gain texture, the buried valleys return to shape. The ancient builders who once stood where waves now break become less imaginary, more tangible. Somewhere in that process, between sound and silence, between erosion and discovery, lies a kind of equilibrium. The planet keeps erasing. We keep rewriting. The sea keeps its secrets. We keep learning to read them. And as this quiet conversation continues, we begin to realize that rediscovery isn't about finding everything. It's about learning how to see the world as it was, layer by layer, with patience equal to the ocean's own. The sea, for all its movement, is a place of silence. Not silence in the absence of sound, because under the surface there is constant noise, but silence in the way it holds its secrets, in how it swallows meaning. Sound travels farther through water than air. A whale's call can cross an ocean. Waves hum across entire basins. Currents whisper against rocks. The ocean is full of sound, but almost none of it is for us. We listen, and we hear patterns and frequencies, but the meaning remains somewhere beneath interpretation. The silence of the sea is not the absence of sound, it's the refusal of translation. For scientists who study what lies beneath, that silence is both a barrier and a presence. Every sonar ping, every echo returned from the depths, is an attempt to break it. The data we collect, the images we create, the maps we draw, they are all ways of asking the same quiet question. What's down there? The ocean replies in its own language, measured in reflections and pressure changes, filtered through miles of shifting water. Sometimes it tells us something clear. Sometimes it answers with noise so dense it might as well be blankness. And in that blankness lies the mystery that keeps the search alive. We imagine the sea as a space of openness, but in reality it's more like a vast, slow vault. Everything that enters it, light, matter, memory, disappears into a kind of suspension. The deeper you go, the less light there is, the less movement, the less life visible to human eyes. Below a few hundred meters, the colors fade until only blue remains. Below 1,000, even blue is gone. Pressure rises relentlessly, crushing, reshaping, compacting. The sea floor, though alive with activity, appears still. It's a stillness that deceives. Sediment drifts like slow snow, covering what falls, preserving it through exclusion. In that darkness, things don't vanish quickly. They fade over ages, dissolving into chemical equilibrium. The silence is geological as much as it is acoustic. It comes from the pace of processes so slow that they seem like stillness. Rocks forming, shells compacting, water circulating through subterranean cracks. Everything that happens there is quiet by our standards, but it is constant. The ocean doesn't forget, it just takes longer to speak. The scientists who spend their lives listening to it describe an odd paradox. They can measure almost everything: temperature, salinity, current speed, chemical composition, yet they often feel they know nothing. The more data they gather, the more complex the picture becomes. The ocean refuses to be reduced. Its silence is not emptiness, its depth in the purest sense, information layered so densely that it becomes unreadable. For archaeologists, that silence is particularly heavy. They search for signs of life in an environment that seems designed to erase them. Every sonar return could mean something, or nothing. Every artifact recovered might be an accident of geology. Even when they find what appears to be clear evidence, walls, tools, carvings, the context that gives those objects meaning has usually been stripped away. The ocean keeps the object but removes the story. A broken pot or a carved stone beneath 30 meters of water can tell us that humans were once there, but it can't tell us why or how. The silence between those facts is immense, and yet that silence holds value. It's a reminder that not everything must be known to matter. The sea's indifference to our curiosity gives it a kind of integrity. It doesn't participate in our need for closure. It carries the remains of extinct species, lost civilizations, and forgotten coastlines with the same quiet impartiality. For every structure we identify, there are thousands more buried beyond reach. For every object preserved, countless others have dissolved into the chemistry of the water. That erasure is not malicious. It's simply what the sea does. It resets, absorbs, balances. Sometimes, in rare conditions, it does the opposite. It preserves perfectly. In the anoxic depths of certain basins where no oxygen penetrates, wood, textiles, and even organic matter can survive for millennia. In the Baltic, ships from centuries ago remain upright, their masts intact, their ropes still coiled on deck. In the Black Sea, where the bottom waters contain hydrogen sulfide instead of oxygen, entire settlements may lie sealed in time. There, the silence is absolute, a stillness so complete that decay itself slows to a stop. These pockets of preservation remind us that the sea's silence isn't only destructive, it's protective too. It can erase or it can cradle, depending on the balance of conditions. The silence of the sea also extends to what it does to human perception. When divers descend, sound changes. It travels faster and differently through water, making it impossible to tell direction. Above a certain depth, the sense of time starts to stretch. Breathing becomes measured, deliberate. Movements slow down. The world narrows to what the light touches. In those moments, the ocean feels infinite not because of its size, but because of its indifference. It doesn't react. It doesn't echo back. You're surrounded by something that existed long before you and will exist long after. Every small sound, your breathing, your bubbles, the hum of distant machinery, becomes immense against that backdrop. For those who explore it regularly, the experience changes their sense of history. On land, we're used to thinking in visible layers. Ruins built over ruins, traces of people left behind. Underwater, time collapses. Everything is simultaneous. You can swim over a modern shipwreck and then, a few meters away, touch the stone of a structure thousands of years older. The sea doesn't arrange history in sequence, it mixes it. That mixture is part of its silence. It refuses to separate the ancient from the recent, the natural from the human. There's also a silence of scale. The ocean is vast beyond comprehension. Even with satellites and sonar, we've mapped only a fraction of its floor in detail. The rest remains blank on our charts, marked simply as depth and darkness. The unknown isn't just theoretical, it's physical. Most of the seafloor is still unseen, unexplored, unmeasured. Somewhere in that immensity may lie evidence that could rewrite history. Somewhere else there is nothing at all but rock and silt. The ratio of what we know to what we don't is staggering. Every new survey, every expedition chips away at that blankness, but only slightly. The more we map, the more we realise how much remains unmapped. The silence doesn't shrink, it deepens. The ocean's refusal to reveal everything at once makes discovery meaningful. Each new find, a submerged village, a lost river channel, a fossilised reef, is a small interruption in the quiet. But the quiet always returns. The silence also has a moral weight. It's a reminder of scale, of proportion, of humility. When we talk about lost civilizations or vanished coastlines, we often imagine ourselves as detectives, piecing together a mystery. But the truth is, we are the briefest of guests in a story far older than us. The sea's silence reminds us that the planet's memory extends beyond human memory. We are not its first observers, and we will not be its last. The ocean's patience dwarfs ours. In that sense, the silence is comforting. It means the Earth continues, regardless of what we know. The drowned plains and buried valleys still exist in their own way, transformed but not gone. The minerals from ancient buildings dissolve and reassemble in coral reefs. The carbon from long-dead forests feeds plankton. The cycle of life, death and transformation continues without pause. The sea's quiet persistence is the background against which all our activity unfolds. Sometimes, this perspective feels heavy. The idea that the sea erases everything we build can seem like a kind of futility. But it can also be a relief. To know that nothing is truly permanent frees us from the illusion that it should be. The ocean teaches the same lesson that time does. Endurance isn't about staying unchanged. It's about continuing to participate. The silence of the sea isn't emptiness, it's equilibrium. It's the sound of things continuing at a scale too large for us to hear. Even the creatures that live in the deep seem shaped by that silence. Many have no eyes, no pigment, no need for speech. They navigate through vibration, through faint chemical signals, through instinct refined over millions of years. To them, the absence of light and noise isn't alien, it's normal. The same environment that feels isolating to us is home to them. The silence is filled with meaning we can't perceive. That, too, is a kind of message. Not everything that exists was meant to be understood by us. When we listen to the ocean with our instruments, we sometimes catch strange sounds, low-frequency hums, clicks and pulses that don't match any known source. Some are geological, caused by ice breaking or underwater landslides. Others remain unexplained. The bloop, recorded in 1997 by the US National Oceanic and Atmospheric Administration, was one of these. For years it puzzled scientists. It was powerful, low, and echoed across vast distances. Eventually it was traced to ice fracturing in Antarctica, but for a time it felt like the ocean had spoken in a voice no one could recognize. It reminded us how small we are inside its volume of sound. That kind of mystery still happens. Every expedition picks up signals no one expected. Bursts of noise, sudden silences, shifts in background patterns. Each one adds to the texture of the ocean's soundscape. Over time, researchers have begun to treat this soundscape as a kind of living archive. By comparing recordings over years, they can track changes in ecosystems, currents, and even human activity. The silence in this context becomes a measure of disruption. The noisier the ocean becomes from ships, drilling and sonar, the less space there is for the natural voices within it. The true silence is disappearing, replaced by a mechanical hum. Even that is a record, a sign of our presence written into the ocean's acoustics. There's a quiet irony here. The more we listen, the more we realise how much sound there actually is, and how little of it belongs to us. The ocean's silence isn't real silence, it's scale. Its sounds are simply too vast, too deep, or too constant for us to perceive them as anything but stillness. When we finally hear them, when our instruments tune finely enough, they become part of a larger pattern, one that connects the living and the non-living, the past and the present. Sometimes, when deep-sea explorers describe their work, they speak of it almost as a form of meditation. The long hours of drift, the faint illumination, the constant hum of machinery, the distance from the surface, it all creates a sense of detachment from ordinary life. In that detachment, perspective changes. The urgency of discovery fades, replaced by a quieter form of awe. The ocean's silence becomes a mirror for the mind, reflecting not absence but patience. It reminds us that understanding doesn't have to mean control. It can mean coexistence, a willingness to let mystery remain mystery. Every sonar pulse, every dive, every core sample is an interruption of that silence, but only briefly. Once the instruments stop, the ocean returns to its rhythm. The sand settles, the currents resume their flow. The sea folds the disturbance back into itself, as if smoothing over a wrinkle. Its quiet resets vast and unbroken. The silence is always waiting, patient, immense, older than any civilization, indifferent to what we ask of it. And so, we keep listening. We keep mapping, sampling, and scanning, aware that most of what we seek may never be found. The silence of the sea is not a problem to solve. It's a condition to understand. It's the medium through which memory travels, the vast pause between the sentences of Earth's story. Somewhere within that pause, between the noise of discovery and the stillness of time, lies the space where meaning forms, a moment of recognition that we too are part of that silence, temporary and listening. And as the currents move unseen, carrying traces of what came before, the quiet continues, not empty, not cold, but full of all the stories the sea has kept, waiting for the patient hands and careful instruments that might one day learn to hear them as more than echoes. Every wave that reaches the shore is carrying something older than sound. It isn't only water moving, it's time itself, folding back upon us in motion. The sea is full of memory. Every drop holds fragments of stone, traces of life, and the faint chemistry of things that once stood where the waves now fall. When we stand by the ocean and listen, even without realizing it, we're hearing the resonance of a planet that has been speaking in slow rhythms for billions of years. The echo that reaches us isn't metaphorical, it's physical, measurable, and constant. It's the continuation of everything that has ever moved within the sea. That echo connects us to worlds long gone. The lands that once existed beneath these waves, the civilizations that might have built upon them, the forests that covered them, the rivers that cut through them, they haven't disappeared entirely. They've been reabsorbed into the Earth's cycles. The carbon from their wood is now in the air we breathe. The minerals from their stones have dissolved into the oceans that lap at our feet. The same water that eroded their coastlines is the water that sustains us. We live surrounded by the after-image of what came before. When we talk about the past, we often imagine it as something distant, but the evidence of it never travels far. Every current that moves across the sea carries suspended dust, microscopic shells, fragments of plankton, and traces of metals released from ancient rock. Those materials drift, settle, and rise again through the food web, cycling endlessly. Some of them have been in motion for longer than any civilization has existed. The fish that swim near the surface today might carry within them molecules from the plants that grew on Doggerland's plains 10,000 years ago. The air above the Pacific contains water vapour that once rained on continents, now vanished. Time disperses, but it doesn't disappear, it circulates. The echo that reaches us takes many forms. Some are obvious: archaeological discoveries, sonar images, sediment cores. Others are more elusive: patterns in mythology, similarities in symbols and stories, echoes of cultural memory that survive displacement. The floods and drownings described in ancient tales may not be literal accounts, but they preserve an emotional truth, the memory of loss, of change, of landscapes swallowed by the sea. Those memories carried forward through generations, disguised as stories, are echoes too. They are the way the past continues to speak, even when the evidence has been erased. The scientific echoes are quieter but no less profound. They live in isotope ratios, in oxygen levels trapped in microscopic bubbles, in the layering of marine sediments. Instruments read them with precision beyond human perception, but what they describe is still a story. The rise and fall of ice, the expansion of oceans, the migration of shorelines. When scientists say the sea level rose by 120 metres since the last glacial maximum, they're reciting an epic written in molecules. The ocean is its own historian, writing not in language but in chemistry. We tend to separate the material and the emotional, but the truth is they're parts of the same echo. The data tells us what happened. The stories tell us what it felt like. The rise of the oceans after the Ice Age wasn't a single event. It was a process that lasted thousands of years, and it touched every coastal community on Earth. Each generation must have watched familiar landmarks disappear. Fields turn to marshes, and rivers widen into bays. They adapted, moved inland, and carried their memories with them. The echo of their experience survives in both the geology beneath us and the myths we still tell. Every coastline is a conversation between those two forms of memory, what the Earth remembers and what we do. Modern technology has made it easier to detect those ancient conversations. Instruments listen to the ocean's pulse in ways our ancestors could not. Sonar, LiDAR, magnetometry, sub-bottom profiling. All of it expands our hearing range into the realm of the inaudible. But even as we map more of the sea floor, the echo that reaches us remains faint, filtered by time and distance. The deeper we look, the more we realize that the sea's archive isn't infinite, it's delicate. The smallest shift in current, the smallest disturbance can erase evidence that took millennia to form. The ocean's memory survives only through balance, and still, it speaks. Sometimes it does so through coincidence, like the way pollen preserved in deep-sea cores matches plants described in ancient texts, or through chemical signatures that confirm flood patterns once recorded as legend, or through the sudden rediscovery of a site thought lost forever. Each time we find one of these connections, we hear the echo becoming slightly clearer. It doesn't resolve into certainty, but into recognition. It tells us that what we imagined about the past might not have been so far from truth after all. The echo also comes through sound itself. The ocean is full of background resonance, much of it made by the planet. The low-frequency hum of waves interacting with the seafloor, the vibrations of tectonic movement, the faint roars of underwater volcanoes. All of these contribute to what scientists call the seismic hum. It's the Earth's own music, a near-constant vibration that envelops the planet. Recorded and amplified, it sounds like a deep, slow heartbeat. It's the literal sound of motion continuing through rock and water. When you hear it, you're hearing the pulse of everything that came before, still moving. In the same way, the magnetic field of the Earth carries an echo of its history. The minerals in basalt formed on ancient seafloors retain the orientation of the planet's magnetic poles at the time of their creation. By studying those orientations, scientists can trace the drift of continents and the opening of oceans. Each rock is a compass frozen in time, pointing toward an ancient north. Those tiny alignments, invisible to the eye, collectively tell the story of continents separating and rejoining over hundreds of millions of years. The sea itself is part of that record, continually erasing and rewriting its own geography. For humans, these echoes have always had a deeper pull. We are drawn to the idea that something of the past still calls to us, that the ruins beneath the waves are not silent but waiting. There's a reason lost civilizations fascinate us so much. They represent a version of ourselves extended backward into time, a reassurance that intelligence, creativity and meaning existed before us and might outlast us. When we imagine the first builders standing on coasts that are now seabeds, we're really imagining the continuity of human thought. Their stones, if they remain, are less important than the impulse that placed them. The echo that reaches us from their world is not in the stone, but in our curiosity about it. That curiosity is its own form of echo. Every scientific expedition, every story told, every question asked about what might lie beneath the sea, repeats a pattern as old as thought itself, the desire to connect with what came before. In that sense, rediscovery is not a return to the past, but a dialogue with it. We listen to the ocean not to hear it confirm our theories, but to feel that continuity, that line connecting us to the forgotten coasts, the drowned valleys, the lives erased but not lost. The echo reminds us that we are participants in the same long rhythm. Another generation standing on temporary land, watching the water move closer. Even the tools we build to explore the sea, our machines, sensors, satellites, are part of that rhythm. They are our answer to the echo. Each new technology extends the conversation a little further, translating vibrations and reflections into understanding. But no matter how advanced our tools become, they will never silence the mystery entirely. The ocean's voice will always remain partly beyond translation. That's not failure, it's balance. Some distance must remain between the question and the answer, otherwise the wonder disappears. Sometimes the echo reaches us not through discovery, but through emotion. Standing on a shoreline at night, hearing the long draw and retreat of the tide, the sound carries something deeper than physics. It's recognition. The same waves have been arriving here for thousands of years, hitting the same rocks, shaping the same curves of coast. Generations have stood in the same place, listening. The ocean connects those moments into one unbroken sensation. The echo isn't just in sound, it's in the shared act of listening. The sea reflects our own impermanence back to us in its most honest form. It doesn't promise that anything will last, but it shows that everything continues. The molecules that make up our bodies have passed through oceans countless times. The calcium in our bones was once part of shells, reefs, and skeletons that sank to the sea floor long before humans existed. The salt in our blood mirrors the salinity of the ocean itself, a chemical reminder of where life began. When we listen to the sea, we're hearing the environment that made us possible. The echo that reaches us isn't just historical, it's biological. It's the resonance of origin. That origin is still ongoing. The sea continues to shape us, both physically and culturally. It defines our climates, feeds our populations, and determines the rhythms of our economies and migrations. Its rising levels, once again, are redrawing coastlines. The same processes that buried ancient lands beneath water are now repeating, slowly and without pause. Our cities, like theirs, stand at the edge of change. The echo from the past is becoming the warning of the present. Scientists measuring modern sea level rise often describe their data in terms of centimetres per decade. It sounds small, but across time it's immense. A few centimetres today could mean metres in the future. The pace mirrors the ancient melts that drowned the Ice Age coasts. The difference now is awareness. We know what's coming. The same slow silence that once consumed Doggerland or the Gulf Oasis is approaching again, only this time we can measure it, predict it, model it. The echo of the past doesn't just reach us, it instructs us. It reminds us that adaptation, not permanence, is the rule of survival. The echo also carries humility. It reminds us that everything we build, no matter how strong, will one day belong to the same cycle. The glass, the steel, the concrete, all will dissolve and re-enter the Earth's chemistry. The cities we call modern will become the sediments of the future, and perhaps tens of thousands of years from now, someone or something will search for traces of us beneath a new sea, wondering what we were, just as we now wonder about those who came before. The ocean will remember us the way it remembers everything, not in form but in residue, and perhaps that is enough. The echo that still reaches us is not a promise of recovery, but a gesture of continuity. The world doesn't need to preserve our exact image to preserve our meaning. Every discovery we make beneath the waves is proof that the past still moves through the present, that nothing, once part of this planet, ever truly leaves it. The sea is the bridge between what was and what is, carrying the residue of both. When we listen carefully enough, we begin to sense that the echo isn't only coming from the ocean to us, it's also moving the other way. Our own voices, our sonar pulses, our ships, our questions, are entering that same medium, blending with the soundscape of the planet. The ocean is recording us now in its own way. Our signals travel through it just as ancient vibrations once did. Someday those echoes may be what another intelligence finds, faint but traceable, rippling through layers of time. The ocean will carry them onward, indifferent and faithful, long after we've stopped asking. And as we stand again at the edge of the tide, listening, it becomes clear that the sea has never been silent at all. It has been speaking the entire time, in the language of movement, chemistry, and persistence. The echo that reaches us is the voice of the planet continuing to think, to remember, to evolve. It doesn't call for us to solve it, only to recognize that we are part of its ongoing resonance. A brief note in a symphony too vast to finish, but perfect in its endless repetition, washing against the shore again and again, with the quiet patience of everything that has ever been.